Hello everyone. Today we will study equations of lines. In general, a linear equation with only two variables, x and y, represent a line in the xy plane. What's a linear equation? In general, the standard form of a linear equation looks like this. ax plus by equal to c, where a, b, c are constants. Constants means real numbers, so a, b, c could be any numbers. And a, b, they are not both zeros. A, b, they are not both zeros. That's called a standard form of a linear equation. Next, let's look at an example. Graph each of the following linear equations. First example, x minus 2y equal to 2. In order to sketch the graph for this equation, we try to make a table. Make a table for x and y. Now look at x and y. Here, the expression of y looks more complicated. So we choose a value for y and then solve for x. That will be easier. Here, expression of y looks more complicated. So we choose some value for y and then solve for x. It will be easier. So here, let's pick some value for y. In general, we pick some negative value and positive value for y. So I can pick negative 2, negative 1, 0, 1, and 2. Pick some value for y. Some positive number, some negative number. Then plug in its value, plug in its y value, and solve for x. When y is negative 2, I have x minus 2 times negative 2 equal to 2. 2 times negative 2. Negative 2 times negative 2 is positive 4. Double negative is positive. Then I can subtract 4 from both sides. I get s equal to negative 2. So when y is negative 2, x is negative 2. Next, when y is negative 1, what do we get? Plug in negative 1 for y. We get x minus 2 times negative 1 equal to 2. Negative 2 times negative 1 is positive 2. Then I can subtract 2 from both sides. I get s equal to 0. So when y is negative 1, s is 0. Next, plug in 0 for y. If I plug in 0 for y, I get s minus 2 times 0 equal to 2. 2 times 0 is 0. I get x minus 0 equal to 2. And we know that x minus 0 is x. So we get s equal to 2. When y is 0, s is 2. Next, plug in 1 for y. I get when y is 1, I have x minus 2 times 1 equal to 2. 2 times 1 is 2. Then I can add 2 to both sides. I get s equal to 4. So when y is 1, s is 4. Next, when y is 2, what's x here? I plug in 2 for y. I get x minus 2 times 2 equal to 2. 2 times 2 is 4. Then I can add 4 to both sides. I get s equal to 6. So when y is 2, s is 6. Now we have this point here. I can plug the point and sketch the graph. Zero in the middle. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Then plot points. First point, negative 2, negative 2. Where s is negative 2, y is negative 2. That's the first point. Second point, 0, comma, negative 1. When s is 0, y is negative 1. It's here. Next point, 2, comma, 0. when x is 2, y is 0. Next point, 4, 1, when x is 4, y is 1. It's here. Next point, 6, 2, when x is 6, y is 2. Then connect all points, we can make a line. Connect all these points, we can make a line. That's the graph of this equation. That's the graph of this equation. Next example, 3x plus y equal to negative 3. In order to graph this equation, we make a table for x and y. We can either pick values for x or y, whichever is easier. In this equation here, expression of x looks more complicated. So we can pick some value for x and then solve for y, it will be easier. Here, expression of x looks more complicated. So I can pick some value for x and then solve for y, it will be easier. So let's pick some value for x. In general, we pick some positive value and some negative value for x. So here we can pick negative 2, negative 1, 0, 1, and 2. Pick some positive value for x and some negative value for x. Then plug in each x, solve for y. When x is negative 2, I have 3 times negative 2 plus y equal to negative 3. 3 times negative 2 is negative 6. Then I can add 6 to both sides. I get y equal to 3. That means when x is negative 2, y is 3. Next, x equal to negative 1. We plug in negative 1 for x and then solve for y. We get 3 times negative 1 plus y equal to negative 3. 3 times negative 1 is negative 3. Then I can add 3 to both sides. If I add 3 to both sides, negative 3 plus 3 is 0. I get y equal to 0. So when x is negative 1, y is 0. Next, when x is 0, we plug in 0 for x. We get 3 times 0 plus y equal to negative 3. We know that 3 times 0 is 0. We get 0 plus y equal to negative 3. 0 plus y is y. We get y equal to negative 3. So when x is 0, y is negative 3. Next, x equal to 1. Plug in 1 for x. We get 3 times 1 plus y equal to negative 3. We know that 3 times 1 is 3. Next, I can subtract 3 from both sides. I get y equal to negative 6. That means when x equal to 1, y equal to negative 6. Next, x equal to 2. We plug in 2 for x. We get 3 times 2 plus y equal to negative 3. 3 times 2 is 6. Here I can subtract 6 from both sides. I get y by itself. Y is negative 9. That means when x is 2, y is negative 9. Now we can plot these points and make the graph. That's an x-axis, that's an y-axis. You have 0 in the middle. Numbers from the right are positive. Numbers from the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Now let's plot points. First point is negative 2, 3. That means when x is negative 2, y is 3. That's the first point. Next point, x is negative 1, y is 0. Negative 1, 0. When x is negative 1, y is 0. The point is here. Next point, 0, negative 3. That means when x is 0, y is negative 3. When x is 0, y is negative 3. It's here. Next point, 1 comma negative 6. That means when x is 1, y is negative 6. When x is 1, y is negative 6 is here. Next point, 2 comma negative 9. That means when x is 2, y is negative 9. When x is 2, y is negative 9. Then connect all these points, we can make a line. Connect all these points, we can make a line. That's the graph for this equation. Next example, y equal to 3. This is a linear equation. But in this equation, there's no x. If there's no x in the equation, what does it mean? What does y equal to 3 means? Y equal to 3, it means for all x value, for any x values, y is always 3. Y equal to 3 means for all x values, y is always 3. It doesn't matter what x is, y is always 3. Now let's make a table. How do we make a table here? We'll make a table for x and y. Y is always 3. It doesn't matter what we choose for x. Y is always 3. Y is always 3. It doesn't matter what we choose for x. Y is always 3. X could be any numbers. So let's pick some value for x. We can pick some negative value and some positive value for x. So for any x, y is always 3. Then plot the points and sketch the graph. Then plot the points and sketch the graph. That's an x-axis. That's an y-axis. 0 in the middle. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Now let's plot points. First point, negative 2 comma 3 is here. That's negative 2 comma 3. Next point, negative 1 comma 3. Where x is negative 1, y is 3. Next point, 0 comma 3. Where x is 0, y is 3 is here. Next point, 1 comma 3. Where x is 1, y is 3. Next point, 2 comma 3. Where x is 2, y is 3. Then connect all points, we can make a line. So that's the graph of this equation, y equal to 3. It's a horizontal line passing through 3. It's a horizontal line passing through 3. Next example. How do we graph the equation x equal to negative 2? In this equation, there's no y. This is a linear equation. But in this equation, there's no y. What does it mean? In the equation, if there's no y, it means for all y values, it doesn't matter what y is, x is always negative 2. This equation x equal to negative 2 means it doesn't matter what y is, x is always negative 2. Now let's make table for x and y. Let's make table for x and y. We know that x is always negative 2. It doesn't matter what y is, x is always negative 2. Then we can pick some value for y. We can pick some value for y. Pick some positive value for y, some negative value for y. We can pick negative 2, negative 1, 0, 1, 2. Pick some negative value for y and some positive value for y. Then we can plot the points and sketch the graph. assume that's x-axis, that's not y-axis. Number in the middle is 0. Number to the right are positive. Number to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Then plot the points. First point, -2, -2. That means when x is -2, y is -2. It's here. That's the first point. Second point, -2, -1. That means when x is -2, y is -1. It's here. Next point, -2, 0. That means when x is -2, y is 0. Next, -2, 1. That means when x is -2, y is 1. Point is here. Next, -2, 2. That means when x is -2, y is +2. Point is here. Then connect all these points, we can make a line. That's a graph of this equation. That's a graph of this equation. That's a vertical line passing through -2 in the x-axis. That's a vertical line passing through -2 on the x-axis. So those are examples of linear equations. For any linear equation, its graph is always a straight line. For any linear equation, its graph is always a straight line. It's always a straight line. Next, let me introduce slope of a line. What's the slope of a line? In general, the slope of a line represents how fast a line is increasing or decreasing from left to right. In general, the slope of a line represents how fast a line is increasing or decreasing from left to right. But how do we find the slope? In order to find the slope, we pick 2 points on the line first. So first of all, let S1, Y1 and S2, Y2 be 2 points on a line. Let S1, Y1, S2, Y2 be 2 points on a line. For example, that's a line. We have a line here. There are 2 points, S1, Y1, and S2, Y2 on the line. How do we find the slope for this line? Slope is defined to be rise over long. Slope in general is defined to be rise over long. That's rise. That's called rise. That's called long. Here, rise is the vertical change. Rise represents a vertical change. So, rise is the vertical change, change of y. Change of y is called a rise. What's long? Long is the horizontal change. Long is the horizontal change, which is the change of x. And we know that for change of y, we take y2 minus y1. For change of y, we take y2 minus y1. So y is equal to y2 minus y1. Long is the change of x, which is x2 minus s1. s2 minus s1 is the long. So slope is defined to be rise over long. Slope is defined to be rise over long. Rise over long. Rise is change of y, and long is change of x. Change of y is y2 minus y1. Change of x is s2 minus s1. So that's how we define slope. Change of x is x2 minus s1. That's how we define slope. So let s1, s2, the s1, y1, s2, y2 be 2 points on a line. Then the slope of the line is defined as we use M to represent slope. Slope of a line is defined as y2 minus y1 over s2 minus s1. That's how we define slope. Next, let's look at some examples. In the previous example, find the slope of each line. In the previous example, there are 4 lines. We try to find the slope for each line. In order to find the slope of a line, we need to first of all pick 2 points from the line. So let's pick any 2 points from the line. Let me pick this point, 0, -1. And this point, 4, 1. It could be any 2 points. Let me pick any 2 arbitrary points from the line. 4, 1. Find the slope based on these 2 points. In general, we call the first point S1, Y1. Call the second point S2, Y2. Then find the slope for this line. Use the formula to find the slope. The formula says Y2 minus Y1 over x2 minus s1. In the numerator, 1 minus -1, double negative is positive. 1 plus 1 is 2. In the denominator, 4 minus 0 is 4. We get 2 over 4. If I simplify 2 over 4, I get 1 over 2. I divide top and bottom by 2, I get 1 over 2. That's the slope of this line. So the slope of this line is 1 over 2. But here, I have a question. What if I pick different points? What if I pick 2 different points? What if I pick this point and this point? What do I get for the slope? What if I pick the first point, -2, -2, and the last point, 6, 2? What do I get from the slope? Do we get the same slope? Let's try. Let me call the first point S1, Y1. Call the second point S2, Y2. Then apply the slope formula. Slope formula says Y2 minus Y1 over S2 minus S1. So plugging Y2 minus Y1 is 2 minus -2. X2 minus S1 is 6 minus -2. Y2 minus Y1 over S2 minus S1. Then simplify. In the numerator, we get 2 minus -2. Double negative is positive. 2 plus 2 is 4. In the denominator, we get 6 minus -2. Double negative is positive. 6 plus 2 is 8. I get 4 over 8. If I simplify 4 over 8, I can divide top and bottom by 4. I get 1 over 2. So the slope is 1 over 2. We get exactly the same slope. We get exactly the same slope as what we have here. So in order to find the slope of a line, we can pick any 2 points from the line. It doesn't matter what point we pick, the slope is always the same. So we can pick any 2 points from the line. Next, for the slope from the second line. So same thing, we pick 2 points from the line. For the second line here, pick any 2 points from the line. Let me pick -2, 3. And 1, -6. It could be any points. 1, -6. Pick any 2 points from the line, and then find the slope. Let's call the first point S1, Y1. Call the second point S2, Y2. Then use the slope formula. Slope formula says Y2 minus Y1 over S2 minus S1. Then plugging Y2 minus Y1 is -6 minus 3 over S2 minus S1. That's 1 minus -2. In the numerator, -6 minus 3. Consider this as -6 plus -3, which is -9. For the denominator, we have 1 minus -2. Double negative is positive, so we got 1 plus 2. 1 plus 2 is 3. Then, -9 over 3 is -3. That's the slope of the second line. That's the slope of the second line. For the third line, do the same thing. Pick 2 points. For the third line, do the same thing. Pick any 2 points on the line. Let me pick this point, -1, 3, and 2, 3. It could be any 2 points. Let me pick 2, 3. It doesn't matter what point we pick. The slope is always the same. Then find the slope. Let's call the first point S1, Y1. Second point S2, Y2. Then for the slope, we use Y2 minus Y1. I get 3 minus 3 over x2 minus s1. That's 2 minus -1. In the numerator, 3 minus 3 is 0. In the denominator, 2 minus -1. Double negative is positive. 2 plus 1 is 3. 0 over 3 is 0. So slope of this line is 0. Next, for the slope for the fourth line. So in order to find the slope, we can pick any 2 points from the line. Pick any 2 points from the line. Let me pick this point. -2, -1, and -2, 0. Could be any 2 points. Let me pick these 2 points. -2, -1, and -2, 0. Pick any 2 points from the line. Then use slope formula to find the slope. Then we call the first point S1, Y1. Call the second point S2, Y2. Then plug into the slope formula. The slope formula says Y2 minus Y1, 0 minus -1, over x2 minus s1, -2 minus -2. In the numerator, 0 minus -1, double negative is positive. We get 0 plus 1, which is 1. That's the numerator. In the denominator, what do we get? We have -2 minus -2. We know that double negative is positive. So we get -2 plus 2, which is 0. What's 1 over 0? Well, the denominator cannot be 0. When we have a fraction, denominator cannot be 0. If the denominator is 0, this fraction is undefined. So this slope is undefined. This slope is undefined. Denominator cannot be 0. If the denominator is 0, this number is undefined. Next, let me show you some properties of the slope of a line. If the slope of a line is greater than 0, then the line is increasing from left to right. In our first example, the slope of a line is half, which is greater than 0. If the slope of a line is greater than 0, then the line is increasing from left to right. That's the first property of the slope. The second property says, if the slope of a line is less than 0, then the line is decreasing from left to right. In our second example here, the slope of a line is -3, which is less than 0. If the slope of a line is less than 0, then the line is decreasing from left to right. From left to right, the line is decreasing. That's the second property of the slope of a line. The third property says, if the slope of a line is 0, then the line is horizontal. If the slope of a line is 0, then the line is horizontal. In our example 3 here, the slope of a line is 0. Then we know that the line here is horizontal. If the slope of a line is 0, then the line is horizontal. That's the third property. The fourth property says, if the slope of a line is undefined, if the slope of a line is undefined, then the line is vertical. In example 4 here, the slope of a line is undefined, and then we know that the line is a vertical line. That's the fourth property. Note, a horizontal line always has the form y equal to b. A horizontal line always has the form y equal to b. Y equal to b, it represents a horizontal line passing through b in the y-axis. In example 3 here, horizontal line has the form y equal to b. Horizontal line has the form y equal to b. And horizontal line always passing through b in the y-axis. Here b equal to 3, so it pass through 3 in the y-axis. Horizontal line always has the form y equal to b. It represents horizontal line passing through b in the y-axis. Here b is 3, so this horizontal line passing through b in the y-axis. And similarly, a vertical line always has the form s equal to a. This expression s equal to a represents a vertical line passing through a in the x-axis. In this example here, this equation s equal to a number represents a vertical line. This vertical line passing through -2 in the x-axis. Here, our letter a is 2. So that's a vertical line passing through -2 in the y-axis. Here, a is -2. So that's a vertical line passing through -2 in the x-axis. Next, let me show you a different way to graph a line. We know that in general, when we try to graph a line, we can make a table for x and y, find the points, and plot the points. Then, by connecting the points, we can graph the line. This way works, but it may be too complicated. It may be too much work. Next, let me show you a simpler way to graph a line. Think of this. Passing through any 2 points, we know that passing through any 2 points, we can always graph a line. Passing through any 2 points, we can always graph a line. That means, for any line, if I can find 2 points on the line, then by connecting 2 points, I can graph the line. And we know that in general, for any line in the xy plane, it has an s-intercept and a y-intercept. In general, a line in the xy plane has an s-intercept and a y-intercept. By connecting the intercepts, I can graph the line. By connecting the intercepts, I can graph the line. And in general, finding the s and y-intercepts is easier than making a table for x and y. In general, finding the s and y-intercepts is easier than making a table for x and y. Now, let's use this new technique to graph a line. Next, let's graph a line using this new technique. First example, 2x plus 3y equal to 6. How do we graph this line? Let's try to find the x and y-intercepts first. In general, finding the x and y-intercepts is easier than making a table for x and y values. So let's find the intercepts here. For an x-intercept, we set y equal to 0. For an x-intercept, set y equal to 0. So we plug in 0 for y. I get 2x plus 3 times 0 equal to 6. We know that 3 times 0 is 0. And 2x plus 0 is 2x. So we get 2x equal to 6. And then divide both sides by 2. I get s equal to 3. So the x-intercept is 3, 0. When we write a point, s coordinate always comes first. When we write a point, s coordinate always comes first. Next, for the y coordinate, for the y-intercept, we set s equal to 0. Then plug in 0 for x, solve for y. Plug in 0 for x, solve for y. we get 2 times 0 plus 3y equal to 6. We know that 2 times 0 is 0, and 0 plus 3y is 3y. We get 3y equal to 6. Next, I can divide both sides by 3. I get y equal to 2. So the y-intercept is 0, 2. When we write a point, we must write the s coordinate first. So the y-intercept is 0, 2. Then we plot s and y-intercepts. Then we can plot s and y-intercepts. That's x-axis. That's the y-axis. We have 0 in the middle. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Then plot the s and y-intercepts. S-intercept is 3, 0 is here. Y-intercept is 0, 2 is here. Then by connecting 2 points, we can make a line. And this line is the graph of this equation. This line is the graph of this equation. In general, finding the s and y-intercepts is easier than making a table for x and y. Next example. (5x minus 2y) equal to 10. Graph this line using the s and y-intercepts. 5x minus 2y equal to 10. So let's find the s-intercept first. For s-intercept, set y equal to 0. For s-intercept, set y equal to 0. Plug in 0 for y, solve for x. Here I get 5x minus 2 times 0 equal to 10. We know that 2 times 0 is 0. 5x minus 0 is 5x. So we get 5x equal to 10. Next, I can divide both sides by 5. I get s equal to 2. So the s-intercept is the point 2, 0. Then do the same thing for the y-intercept. For the y-intercept, set s equal to 0. Plug in 0 for x and then solve for y. Here I get 5 times 0 minus 2y equal to 10. We know that 5 times 0 is 0. 0 minus 2y is negative 2y. 5 times 0 is 0. 0 minus 2y is negative 2y. And then I can divide both sides by negative 2. I get y equal to negative 5. So the y-intercept is 0, negative 5. For any point, we must write the s coordinate first. So we get 0, negative 5. Here, y equal to negative 5. Then we can plot the s and y-intercepts and graph the line. Assume that's the s-axis, that's the y-axis. 0 is here. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Then plot the s and y-intercepts. S-intercept is 2, 0. It's here. 2, 0. That's an s-intercept. Y-intercept is 0, negative 5. 0, negative 5 is here. That's the y-intercept. Then by connecting 2 points, we can make a line. That's the graph of this equation. Next example. Y equal to half of x plus 3. Y equal to s half of x plus 3. Let's find the s and y-intercepts first. For the s-intercept, set y equal to 0. If I set y equal to 0, I plug in 0 for y. I get 0 equal to half of x plus 3. 0 equal to half of x plus 3. We try to get x by itself. I can first of all subtract 3 from both sides. I make negative 3 equal to half of x. Next, we try to get x by itself. What can we do here? Here I can divide both sides by a half. Divide both sides by a half. On the right side, I get s by itself. On the left side, what's negative 3 divided by a half? Negative 3 divided by a half is the same as saying negative 3 times the reciprocal. Negative 3 can be rewritten as negative 3 over 1 times 2 over 1. Negative number times positive number is negative. Now we multiply numerator to the numerator, denominator to the denominator. I get 6 over 1. And 6 over 1 is 6. So x is negative 6. So the s-intercept is negative 6, comma 0. S-intercept is negative 6, comma 0. For the y-intercept, we say s equals 0, then solve for y. Say s equals 0, solve for y. I plug in 0 for x, then solve for y. Here, y equal to half times 0 plus 3. Half times 0 is 0. 0 plus 3 is 3. So y coordinate is 3. So the y-intercept is 0, comma 3. Moving on a point, we must find the s coordinate first. So that's 0, comma 3. Then let's sketch the graph. Suppose that's an x-axis, that's an y-axis. 0 in the middle. Number to the right are positive. Number to the left of 0 are negative. Numbers above 0 are positive. And numbers below 0 are negative. Let's plot the points. S-intercept is negative 6, comma 0. It's here. Y-intercept is 0, comma 3. It's here. Then, by connecting 2 points, we can make a line. That's the graph of this equation. Next example, 4x minus 3y equal to 0. In order to graph this equation, we first of all try to find the x and y-intercepts. For the s-intercept, we set y equal to 0. Plug in 0 for y and then solve for x. I get 4x minus 3 times 0 equal to 0. 3 times 0 is 0. So I get 4x minus 0 equal to 0. 4x minus 0 stays the same. So I get 4x equal to 0. Then I can divide both sides by 4. If I divide both sides by 4, I get s equal to 0. So the s-intercept here is 0, comma 0. When we write a point, we must write an s coordinate first, and then a y coordinate. For the y-intercept, we set s equal to 0. Then we plug in 0 for x. and solve for y. If I plug in 0 for x, I get 4 times 0 minus 3y equal to 0. We know that 4 times 0 is 0. And 0 minus 3y is negative 3y. Next, I can divide both sides by negative 3. I get y by itself. Negative 0 divided by negative 3 is 0. So the y-intercept here is 0, comma 0. We must run the x coordinate first. S coordinate first, and then the y coordinate. So that's an x coordinate, that's an y coordinate. Next, let's graph the equation. That's an x-axis, that's a y-axis. Number in the middle is 0. The numbers on the right are positive. Numbers on the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Then plot the points. X-intercept is 0, 0, which is the origin is here. Y-intercept is also 0, 0, which is also here. But here we have a problem here. There's only one point. Passing through one point, we can make infinitely many lines. So we don't have a graph for this equation. In this case, what should we do? If an x-intercept and a y-intercept they are the same, what should we do? So in order to graph the equation, we have to pick a different point. In this case, if an x-intercept and a y-intercept they are the same, we must pick different point. So pick different point. We can pick any value, plug in any value for x or y, and then solve for the other value. We can plug in any value for x or y, and then solve for the other value. For example, I can pick any value. If I let x equal to 3, I can pick any value for x and y, and then solve for the other value. Here I let x equal to 3, then I have 4 times 3 minus 3y equal to 0. 4 times 3 is 12. I get 12 minus 3y equal to 0. Next, I can subtract 12 from both sides. If I subtract 12, I get negative 3y equal to negative 12. Then I can divide both sides by negative 3. Negative 12 divided by negative 3 is positive 4. So another point on the curve here is 3, 4. That's another point on the curve, 3, 4. Then plot the point, 3, 4. X coordinate is 3, y coordinate is 4. There's another point on the line. Now we have 2 points. By connecting 2 points, we can make a line. That's the graph of this equation. So, when x-intercept and the y-intercept are the same, that's a special case. If these 2 points are the same, passing through one point, we cannot make a line. We have to pick a different point. In order to pick a different point, we can pick any value for x or y, whichever is easier. Pick any value for x and y. Then solve for the other value, solve for the other coordinate. That's another point. Plot this point, and then passing through 2 points, we can make a line. In the beginning of the class, I showed you one way to write linear equations. It looks like this. The standard form of a linear equation, ax plus by equal to c. Next, I'll show you another way to write linear equation, called the slope-intercept form. The slope-intercept form of a linear equation looks like this. Y equal mx plus b. That's called a slope-intercept form of a linear equation. In this equation, m represents the slope of the line. and B represents the y-intercept of the line. That's why this expression is called slope-intercept form. M represents the slope of the line. B represents the y-intercept of the line. That's why this form is called a slope-intercept form. Next, let's look at some simple examples. Find the slope and the y-intercept. Find the slope and the y-intercept of the line. Represented by the given equation. Find the slope and the y-intercept of the line represented by the given equation. First example, y equal to 3x plus 2. Find the slope and the y-intercept. By matching the formula here, we can see that m is 3, b is 2. By matching the formula here, we can see that m is 3, b is 2. So here we can tell slope of the line is 3. What's the y-intercept of the line? We know that y-intercept is 2. But how do we find the y-intercept? For any line, y-intercept is a point on the y-axis. Y-intercept is the intersection in the y-axis. For any point in the y-axis, its x-coordinate is 0. For any point in the y-axis, its x-coordinate is 0. So for the y-intercept, we must write 0, b. Because for y-intercept, its x-coordinate is always 0. So we must write 0, b. That's an x-coordinate, and that's an y-coordinate. B is always the y-coordinate. So for y-intercept, here we must write 0, 2. Because for y-intercept, its x-coordinate is always 0. That's the slope, and that's the y-intercept. Another example, y equal to half of x minus 4. By matching the formula here, we can see that the slope is half, m is half, b is negative 4. By matching the formula, we can see that m is half, b is negative 4. And m represents the slope, b represents the y-intercept. So here the slope is 1 over 2. For any equation in the form of y equal to ms plus b, the number in front of x is the slope, and the number by itself is the y-intercept. Here slope is half. Y-intercept is negative 4. But how do we write the y-intercept? Y-intercept is negative 4. How do we write the y-intercept? We know that for the y-intercept, its x-coordinate is always 0. For any y-intercept, its x-coordinate is always 0. So here we must write 0, negative 4. That's the y-intercept of this line. That's the slope of this line. Next example. 3x plus 4y equal to a. How do we find the slope of the line? And how do we find the y-intercept? We know that if we use an old technique, we can pick 2 points from the line. If we use an old technique, we can pick 2 points from the line. Then use the slope formula to find the line. Then use the slope formula to find the slope of the line. But that way may be too complicated. A simpler way is, we can try to rewrite this equation in this form, in the form of y equal to ms plus b. And then the number in front of x is the slope, and the single number by itself is the y-intercept. This way is easier than picking 2 points from the line and then use a slope formula. This way is easier. So let's try to get y by itself. Put an equation in the form of y equal to ms plus b. How can we get y by itself? I can first of all subtract 3x from both sides. If I subtract 3x from both sides, I get 4y equal to a minus 3x. By general, try to write a term of x in the front. In general, try to write a term of x in the front. So here, write it as negative 3x plus a. We try to write a term of x in the front. Next, I can divide both sides by 4. Divide both sides by 4. I get y by itself on the right side. On the left side, negative 3 divided by 4 is not divisible, so I leave it the way it is. Negative 3 over 4x. A divided by 4 is 2. Now I write the equation in the form of y equal to ms plus b. Here I get y by itself. Once I get y by itself, the number in front of x is the slope. Once I get y by itself, the number in front of x is the slope. Here, slope is negative 3 over 4. And a single number by itself, the single number by itself is the y-intercept. For y-intercept, its x coordinate is always 0. For y-intercept, its x coordinate is always 0. So we write 0, 2. That's the y-intercept of this line. Using this way, it's easier than the old technique. In the old technique, we pick 2 points from the line. Then use this formula to find the slope of the line. This way may be too complicated. Doing this way is easier. Get y by itself, and then the number in front of x is the slope. The single number by itself is the y-intercept. Next example. 5x minus 2y equal to 6. How do we find the slope of this line? So first step, we try to get y by itself. Put it in the form of y equal to ms plus b. And then the number in front of x is the slope. And the single number by itself is the y-intercept. So here, let's get y by itself. I can first of all subtract 5x from both sides. On the left side, 4x get cancelled, we get negative 2y by itself. On the right side, we get 6 minus 5x. In general, write the term of x in the front. In general, write the term of x in the front. So here, write it as negative 5x plus 6. Write the term of x in the front. Negative 5x plus 6. Next, we just get y by itself. What we can do here is I can divide both sides by negative 2. So divide both sides by negative 2. On the left side, negative 2 get cancelled, we get y by itself. On the right side, negative 5 over negative 2 is positive 5 over 2. Negative 5 over negative 2 is positive 5 over 2. We leave x on the side. Next, positive 6 divided by negative 2. Positive 6 divided by negative 2. Positive number divided by negative number is negative. 6 divided by 2 is 3. Here I write the equation in the form of y equal to ms plus b. And then we know that the number in front of x is the slope. Once I get y by itself, the number in front of x is the slope. And the single number by itself is the y-intercept. The single number by itself is the y-intercept. For the y-intercept, its x coordinate is always 0. For the y-intercept, its x coordinate is always 0. So we write 0, negative 3. That's the y-intercept, and that's the slope of the line. Next, let me show you how to graph lines using the slope and the y-intercept. First example, y equal to half of x plus 3. In order to graph a line using the slope and the y-intercept, let's first of all find the slope and the y-intercept first. What's the slope here? And what's the y-intercept here? In order to find the slope and the y-intercept, we try to match the form y equal to ms plus b. Once we get y by itself, the number in front of x is the slope, and the single number by itself is the y-intercept. Here, the number in front of x is half, so slope is half. Y-intercept is 3. For the y-intercept, the x-coordinate is always 0, so we write 0, 3. Next, let's try to graph this line. Let's draw the coordinate plane first. That's an x-axis, that's an y-axis. We have 0 in the middle. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Then, when we try to sketch graph, plot the y-intercept first. Plot the y-intercept first. Y-intercept is 0, 3 is here. That's the y-intercept. Next, try to use the slope to find another point. Try to use the slope to find another point. Remember, slope is always rise over long. Slope is always rise over long. So here, the numerator is rise. Rise is 1. And the long is half. Slope is always rise over long. Here, numerator is rise. Denominator is long. Rise over long. So, rise is 1. Long is 2. Go up by 1 unit, and then go 2 to the right. Rise over long. Rise is 1. Long is 2. That's the second point. Rise is 1. Long is 2. That's the second point. The coordinate of this point is 2, 4. The coordinate of this point is 2, 4. And then, connect 2 points, we can make a line. Connect 2 points, we can make a line. That's the graph of this line. Next example. Y equal to 3 over 2 times x minus 2. Graph the equation y equal to 3 over 2x minus 2. In order to graph the line using the slope and the y-intercept, let's find the slope and the y-intercept first. So try to match the form y equal to ms plus b. Once we get y by itself, the number in front of x is the slope, and the single number by itself is the y-intercept. Here, slope is 3 over 2. Y-intercept is the single number by itself. Y-intercept is a single number by itself. And for the y-intercept, x coordinate is always 0. We write 0, negative 2. Next, let's draw the coordinate plane. Zero in the middle. Here is x. That's y-axis. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. In order to sketch graph, let's plot the y-intercept first. Plot the y-intercept first. Y-intercept is 0, negative 2. Plot the y-intercept first. Next, use the slope to find another point. We know the slope is always rise over long. So here, rise is 3. Slope is always rise over long. So here, rise is 3. The long is 2. Rise is 3. Long is 2. So start from the y-intercept. Go up by 3 units. 1, 2, 3. Then go 2 units to the right. 1, 2. Rise over long. Rise. 1, 2, 3. 1, 2, 3. Here. 1, 2, 3 here. Rise by 3 units. Long by 2 units. Rise over long. 1, 2, 3, and wrong is 2. The second point here, the coordinate is 2, 1. The coordinate of the second point is 2, 1. Then by connecting 2 points, we can make a line. By connecting 2 points, we can make a line. That's the graph of this equation. That's the graph of this equation. Next example. Graph of the equation 2x plus 1. Graph of the equation 2x plus 1. First step, try to find the slope and the y-intercept first. Here, the slope is 2. The y-intercept is 0, 1. For the y-intercept, x coordinate is always 0. The y coordinate is a single number here. Number 1 here represent a y-intercept. That's the y coordinate of the y-intercept. For the y-intercept, x coordinate is always 0. Next, let's sketch graph. We have 0 in the middle. That's an x-axis. That's an y-axis. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. In order to sketch graph, let's plot y-intercept first. Let's plot y-intercept first. Y-intercept is 0, 1. It's here. Next, use the slope to find a second point. Slope is usually right over wrong. But if we have a single number, if we have a whole number, we can write number 2 as 2 over 1. Put the inflection form. If we have a whole number, put the inflection form. Then number 2 represents right. Number 1 represents wrong. So if the slope is a whole number, write it as a fraction. And the numerator is right, denominator is wrong. Slope is always right over wrong. So here slope is 2 over 1. Right is 2. 1, 2. Wrong is 1. Right over wrong. Right is 2. Wrong is 1. That's the second point. The coordinate of this point is 1, 3. Then, by connecting 2 points, we can make a line. By connecting 2 points, we can make a line. That's the graph of this line. So if the slope is a whole number, put 1 on the bottom, write it as a fraction. Then use right over wrong to sketch a graph. Next example. Y equal to negative 1 over 3x plus 2. First step, find the slope and the y-intercept first. When we get y by itself, the slope is always a number in front of x. That's negative 1 over 3. The y-intercept here is 2. For the y-intercept, the x coordinate is always 0. So you write 0, 2. For the y-intercept, x coordinate is always 0. So here we write 0, 2. Next, let's graph the equation. Let's graph the line using slope and the y-intercept. Zero is in the middle. That's the x-axis. That's the y-axis. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Now, first of all, let's plot the y-intercept. Here, the y-intercept is 0, 2. It's here. That's the y-intercept, 0, 2. Next, try to use the slope to find a second point. Here, the slope is negative 1 over 3. If the slope is negative, usually attach the negative sign to the numerator. If the slope is negative, usually we attach negative sign to the numerator, write it as -1/3. Then the numerator is the rise, the denominator is the long. Rise over long. Start from this point, rise over long. Find the second point, use rise over long. If rise is -1, we go down by 1 unit. In general, if rise is positive, we go up. If the rise is negative, we go down. So here, go down by 1 unit. Rise is -1, go down by 1 unit. Long is 3, go 3 units to the right. 1, 2, 3. That's the second point. Rise over long. That's rise, that's long. Rise over long. If rise is negative, we go down. Rise is positive, we go up. That's the second point. And the coordinate of this point is 3, 1. Then, by connecting 2 points, we can make a line. By connecting 2 points, we can make a line. That's the graph of this equation. Next example, y equal to -12x minus 1. First step, try to find the slope and the y-intercept. Here the slope is -1/2. The y-intercept is a single number by itself. For the y-intercept, the x-coordinate is always 0. So like 0, -1. Now, let's graph the line using the slope and the y-intercept. Draw the coordinate plane first. We have 0 in the middle, that's the x-axis, that's the y-axis. Numbers to the right are positive. Numbers to the left are negative. And numbers above 0 are positive. Numbers below 0 are negative. Let's plot y-intercept first. Y-intercept is 0, -1, which is here. That's 1 point on the line. Next, try to use the slope to find the second point on the line. If the slope is negative, in general, we attach negative sign to the numerator. If the slope is negative, in general, attach negative sign to the numerator. I get -1/2. So the numerator is the slope. Numerator is the rise. Denominator is the long. Slope is always rise over long. Here, since the rise is -1, we go down by 1 unit. Since the rise is -1, go down by 1 unit. Long is 2. Move 2 units to the right. So rise over long. Here, rise is -1. Long is 2. That's the second point. Rise over long. Rise is -1. Long is 2. The coordinate of the second point is 2, -2. The coordinate of the second point is 2, -2. Then, by connecting 2 points, we can make a line. By connecting 2 points, we can make a line. That's the graph of this equation. Next example, y equal to -3x plus 4. In order to graph the line using the slope and the y-intercept, let's find the slope and the y-intercept first. Once we get y by itself, the slope is the number in front of x, and a single number by itself is the y-intercept. Here, slope is -3. Y-intercept is 4. For the y-intercept, x-coordinate is always 0. So we write 0, 4. For the y-intercept, the x-coordinate is always 0. So we write 0, 4. Now let's sketch the graph. Let's draw the xy plane first. Assume that's an x-axis, that's an y-axis. Number in the middle is 0. And the numbers on the right side are positive. Numbers on the left side are negative. Numbers above 0 are positive. Numbers below 0 are negative. Let's plot the y-intercept first. Y-intercept is 0, 4 is here. That's the y-intercept. Next, let's try to use the slope to find a second point on the line. If the slope is a whole number, put it as whole number over 1. Write it as a fraction. If the slope is whole number, we need to write it as a fraction first. So put negative 3 over 1. If a number is negative, attach the negative sign to the numerator. If the slope is negative, always attach negative sign to the numerator. So put the whole number over 1, then attach the negative sign to the numerator. I get negative 3 over 1. The numerator is the slope, is the rise. Denominator is always the long. Slope is always rise over long. Here, rise is negative 3, means we go down by 3 units. If rise is negative 3, go down by 3 units. 1, 2, 3. Long is 1, go 1 unit to the right. That's rise over long. Rise is negative 3, long is 1. Once we find a second point, by connecting 2 points, we can make a line. Connect 2 points and extend the line. That's the graph of this equation. Connect 2 points, extend the line. That's the graph of this equation. Next example. How do we graph 3x minus 2y equal to 10 using the slope and the y-intercept? How do we graph this line using the slope and the y-intercept? So first step, we try to rewrite the equation in the form of y equal to ms plus b. Rewrite this equation in the form of y equal to ms plus b first. And then the number in front of x is the slope. The single number by itself is the y-intercept. So let's get y by itself first. Here I can first of all subtract 3x from both sides. If I subtract 3x from both sides, I get negative 2y equal to negative 3x plus 10. Usually write x first. Write the term of x first. Then I can divide both sides by negative 2. If I divide both sides by negative 2, I get y equal to 3 over 2. Double negative is positive. I get 3 over 2x. Negative 10. Positive 10 divided by negative 2 is negative 5. Positive 10 divided by negative 2 is negative 5. So first step, get y by itself. Put the equation in the form of y equal to ms plus b first. Then the number in front of x is the slope. The number in front of x is the slope. A single number by itself is the y-intercept. For the y-intercept, its x coordinate is always 0. So like 0, comma, negative 5. That's the y-intercept. Next, let's sketch a graph using the slope and the y-intercept. Let me draw the coordinate plane first. Assume that's an x-axis, that's an y-axis. We have 0 in the middle. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Then let's plot the y-intercept first. Y-intercept is 0, comma, negative 5. That's here. Y-intercept is 0, comma, negative 5. Next, use the slope to find a second point on the line. Slope is always rise over long. So rise is 3, long is 2. Rise is 3 means we go up by 3 units. 1, 2, 3. Long is 2. 1, 2. That's the second point on the line. Rise over long. The second point here is 2, comma, negative 2. Then by connecting 2 points, we can make a line. by connecting 2 points, we can make a line. That's the graph of this line. That's the graph of this equation. Next example. X plus 4y equal to a. We try to graph this equation using slope and a y-intercept. Graph this equation using slope and a y-intercept. First step, we try to find the slope and a y-intercept. In order to find the slope and a y-intercept, first of all, we write the equation in the form of y equal to ms plus b, which means get y by itself on the right side. Then the number in front of x is the slope. The single number by itself is the y-intercept. So let's remove x from left side first. Subtract x from both sides. I get negative 4y equal to, negative x plus a. In general, try to write x in the front. Next, we try to get y by itself. So I can divide both sides by 4. Divide both sides by 4. On the left side, 4 cancel, we get y by itself. On the right side, what do we get? We get negative x over 4. If there's no number here, in the numerator, if there's no number, consider that's negative 1x. Negative x over 4, consider this is negative 1x over 4. If there's no number in the front of x, if there's no number in front of x, consider that's a 1. So we have negative 1 over 4. Put x on the side. Negative 1 over 4x plus a over 4 is 2. So once we get y by itself, that's the slope, that's the y-intercept. So slope is negative 1 over 4. The y-intercept is 2. In general, for the y-intercept, its x coordinate is always 0. So we write 0, 2. For the y-intercept, its x coordinate is always 0. So we write 0, 2. Next, let's sketch a graph based on the slope and the y-intercept. Sketch a graph using the slope and the y-intercept. That's x-axis, that's the y-axis. 0 in the middle. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Let's plot the y-intercept first. Y-intercept is 0, 2. It's here. That's the y-intercept. Next, use the slope to find the second point. Here the slope is negative 1 over 4. In general, if the slope is negative, we attach a negative sign to the numerator. We get negative 1 over 4. That's the rise. That's the wrong. So rise is negative 1. Wrong is 4. If rise is negative 1, we go down by 1 unit. Wrong is 4. We get 1, 2, 3, 4. There's a second point on the graph. And the coordinate of this point is 4, 1. Then by connecting 2 points, we can make a line. By connecting 2 points, we can make a line. That's the graph of this equation. So here we can see that there are 3 ways to graph a line. We can graph a line using the slope and the y-intercept. Or we can graph a line using both the s and y-intercepts. Or we can graph a line by plotting points, by making a table and then plot points for x and y. Next, let me introduce parallel and perpendicular lines. Before I explain to you how to define parallel and perpendicular line, let me show you an example first. Look at this example. Let L1, L2, L3, and L4 be lines defined as these 4 equations. Graph L1 and L2 in the same coordinate plane, and then graph L3 and L4 in the same coordinate plane. Let's graph L1, L2 first. assume that's an x-axis, that's an y-axis. Number in the middle is 0. Number to the right are positive. Number to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Let's graph line L1, L2 in the same coordinate plane. When we try to graph a line, there are 3 techniques. We can graph a line by plotting points, or we can graph a line using the x and the y-intercepts, or we can graph a line using the slope and the y-intercepts. Since these equations are in the slope-intercept form, so it's easier to graph a line using slope and y-intercepts. Since these equations are in the slope-intercept form, so it's easier to graph a line using the slope and the y-intercepts. Let's graph L1 first. For L1, y-intercept is 3. So it goes through 3 in the y-axis. That's one of the points on the line. Next, we try to use the slope to find a second point. Here, the slope is 3 over 4. That means right is 3, long is 4. Right is 3, long is 4. So go up by 3 units. 1, 2, 3. Right is 3, long is 4. 1, 2, 3, 4. Right is 3, long is 4. The second point here is 4, 6. Then by connecting 2 points, we can make a line. That's the graph of L1. That's the graph of L1. Next, let's graph L2. For L2, the y-intercept is -2. Let's plot -2 first. That's the y-intercept, -2. Next, let's use the slope to find the second point. For L2, the slope is 3 over 4. So slope is always right over long. Slope is always right over long. Here, right is 3, long is 4. 1, 2, 3, go up by 3 units, and go 4 units to the right. Right over long, go up by 3 units. 1, 2, 3, long is 4. Move 4 units to the right. 1, 2, 3, 4. This point here is 4, 1. By connecting 2 points, we can make a line. That's L2. Next, let's graph L3 and L4 in the same coordinate plane. Since the equations they are in the slope-intercept form, we can graph the equation using the slope and the y-intercepts. We have 0 in the middle. Numbers to the right are positive. That's an x-axis. Numbers above 0. Numbers to the left are negative. Numbers above 0 are positive. That's the y-axis. Numbers below 0 are negative. So let's graph the line using the slope and the y-intercept. So plot y-intercept first. For L3, y-intercept is 1. Slope is -3 over 2. If the slope is negative, we attach negative sign to the numerator. So we get -3 over 2. Right is -3, long is 2. Right is -3, long is 2. If right is -3, go down by 3 units. 1, 2, 3. Long is 2. 1, 2. That's the second point. Right is -3, long is 2. That's the second point on L3. And the coordinate of this point is 2, -2. By connecting 2 points, we can make a line. By connecting 2 points, we can make a line. That's the graph of L3. That's the graph of L3. Next, let's graph L4. For L4, y-intercept is -2. Y-intercept is -2. slope is 2 over 3. That means right is 2, wrong is 3. Right is 2, wrong is 3. Right is 2, so go up by 2 units. Wrong is 3, move 3 to the right. That's the second point on the line. This point is 3, 0. Once we have 2 points, by connecting 2 points, we can make a line. That's the graph of L4. That's the graph of L4. If we observe the lines, we can see that L1 and L2, it looks like if we extend the line, they never touch each other. If we extend the line, they never touch each other. If two lines, they never touch each other, they are called parallel lines. If two lines, they never touch each other, they are parallel lines. So here we say L1, L2, they are parallel lines. Let's look at L3, L4. If we observe L3 and L4, we can see that they intersect at one point here. L3, L4, they intersect at one point here. And the angle between two lines is about 90 degrees. If we measure the angle, we can see that the angle between two lines is about 90 degrees. If two lines intersect, and the angle between the two lines is about 90 degrees, we say two lines perpendicular. So in this example, we can see that L1, L2, they are parallel lines. If we extend the line, they never intersect each other. So we say they are parallel lines. For L3, L4, at the intersection, the angle between two lines is about 90 degrees. So we say these two lines, L3, L4, they are perpendicular. If the angle between two lines is about 90 degrees, we say two lines perpendicular. So in the above example, we can see that L1, L2, they are parallel to each other. And L3, L4, they are perpendicular to each other. Next, let me give you four more definitions about parallel and perpendicular lines. Next, let me give you a formal definition about parallel and perpendicular lines. Let L1 and L2 be two lines. If their slopes are exactly the same, then we say L1 and L2 are parallel, denoted by this notation. Denoted by this notation, L1 parallel to L2. This notation, this symbol means parallel. If their slopes are negative reciprocal of each other, if their slopes are negative reciprocal of each other, then we say L1 and L2 are perpendicular. Denoted by L1 perpendicular to L2. This symbol means perpendicular. L1 is perpendicular to L2. So in this example, you can see that L1, L2, they have exactly the same slope. That's why they are parallel to each other. And for L3, L4, if we observe their slopes, we can see that they have opposite sign. If we observe L3, L4, we can see that their slope have opposite sign. And the fractions are opposite, has opposite denominator and numerator. The fraction here has opposite denominator and numerator. That's called negative reciprocal. They have opposite sign. And the slopes has opposite denominator and numerator. If they have opposite sign and they have opposite denominator and numerator, we say they are negative reciprocal of each other. If their slopes are the negative reciprocal of each other, then two lines perpendicular to each other. That's how we define parallel and perpendicular lines. Now next, let me give you some practice about negative reciprocal. For each of the following numbers, find its negative reciprocal. Negative reciprocal means two numbers, they have opposite sign, and they have opposite denominator and numerator. Let's look at a simple example here. How do we find a negative reciprocal for 4 over 5? How do we find a negative reciprocal for 4 over 5? So for negative reciprocal, do two things. We first of all change the sign. If a number is positive, change it to negative, and then flip the fraction over. 4 over 5 becomes 5 over 4. This is the negative reciprocal of 4 over 5. Next, negative 7 over 2. Negative 7 over 2. For the negative reciprocal, if it's positive, we make it negative. If it's negative, we make it positive. And then flip the fraction over. 7 over 2 make it 2 over 7. Positive 2 over 7 is the same as 2 over 7. That's how we find negative reciprocal for negative 7 over 2. Next, 3 over 8. So if a number is positive, we make it negative. For the negative reciprocal, we make it negative. And then interchange the numerator and denominator. We get 8 over 3. That's the negative reciprocal of 3 over 8. Another example, negative 5 over 9. For negative reciprocal, if a number is positive, we make it negative. If a number is negative, we make it positive. So this number is negative, we make it positive. Then for 5 over 9, we interchange the numerator and denominator. We make it 9 over 5. Flip the fraction over. 5 over 9 becomes 9 over 5. And positive 9 over 5 is the same as 9 over 5. Next, how do we find the negative reciprocal for number 2? How do we find the negative reciprocal for number 2? First of all, in order to find a negative reciprocal, we need to rewrite a whole number as a fraction first. In order to find a negative reciprocal, we must rewrite the whole number as a fraction first. Number 2 can be rewritten as 2 over 1. Then, for the negative reciprocal, if a number is positive, we make it negative. Then interchange the numerator and denominator. We get 1 over 2. So negative 1 over 2 is the negative reciprocal of number 2. Negative 1 over 2 is the negative reciprocal of number 2. Next, negative 5. How do we find the negative reciprocal for negative 5? So when we have a whole number, we must rewrite the whole number as a fraction first. In order to find a negative reciprocal, we must rewrite the whole number as a fraction first. So we got negative 5 over 1. So negative 5 is the same as negative 5 over 1. In order to find a negative reciprocal, we change the sign. If a number is positive, we make it negative. If a number is negative, we make it positive. 5 over 1 becomes 1 over 5. And positive 1 over 5 is the same as 1 over 5. That's how we find a negative reciprocal for negative 5. So 1 over 5 is the negative reciprocal of negative 5. Next, one over 6. How do we find the negative reciprocal for 1 over 6? If a number is positive, we first of all make it negative. Then interchange the numerator and denominator. We get 6 over 1. Negative 6 over 1 is the same as negative 6. If the denominator is 1, we drop 1. So the negative reciprocal of 1 over 6 is negative 6. Next example, negative 1 over a. How do we find the negative reciprocal? If a number is positive, we make it negative. If a number is negative, we make it positive. Then interchange the numerator and denominator. 1 over a become a over 1. Positive a over 1 is the same as number a. So number a is the negative reciprocal of negative 1 over a. That's how we find negative reciprocals. Next, let's look at some examples about parallel and perpendicular lines. For each of the following pairs of line 1 and line 2, determine whether they are parallel, perpendicular, or neither. First example, line 1 is y equal to 2x plus 5. Line 2 is y equal to 2x minus 4. We try to determine whether line 1 and line 2 they are parallel, perpendicular, or neither. In order to determine whether two lines are parallel or perpendicular, we look at their slopes. If their slopes are the same, then two lines parallel. If the slopes are negative reciprocal of each other, then they are perpendicular. Now look at their slopes. For equations in the form of y equal to ms plus b, the number in front of x is the slope. So the slope of the first line is 2. Slope of the second line is also 2. For equation in the form of y equal to ms plus b, the number in front of x is the slope. Here we have m1 equal to 2, m2 equal to 2. So the slope of two lines are the same. Since the slope of two lines are the same, then we can say line 1 parallel to line 2. If two lines have the same slope, then they are parallel to each other. Next example, line 1 is y equal to negative 3x plus 1. Line 2 is y equal to 1/3 of x plus 2. We try to determine whether two lines are parallel, perpendicular, or neither. So let's look at their slopes. For the first line, if the equation is in the form of y equal to ms plus b, then the slope is the number in front of x, which is negative 3. Similarly, for the second line, the slope is 1/3. If their slopes are the same, then we can say these two lines are parallel. Here we can see that they are not the same. So we can tell L1, L2, they are not parallel to each other. Are they perpendicular? So if the slope of two lines are the negative reciprocal of each other, then two lines perpendicular. Here, are they negative reciprocal? So let's check negative 3. What is negative reciprocal? Negative 3 can be rewritten as negative 3 over 1. If I try to find its negative reciprocal, I change the sign. It's negative, I make it positive. And then flip the fraction over. 3 over 1 become 1 over 3. That's exactly the same as M2. So here we can see that they are negative reciprocal of each other. Since their slopes are negative reciprocal of each other, then we can say two lines perpendicular. Since M1 and M2 they are negative reciprocal of each other, then we can say two lines perpendicular. So L1 is perpendicular to L2. Next example, line 1 is y equal to 2/3 of x plus 4. Line 2 is y equal to 1/3 of x minus 2. We try to determine whether two lines are parallel, perpendicular, or neither. So let's find their slopes first. For equations in the form of y equal to ms plus b, the slope is of the number in front of x. Here the slope of the first line is 2/3. And the slope of the second line is 1/3. Since they are not the same, since M1 and M2 they are not the same, we can say that these two lines, L1 and L2, they are not parallel. But are they negative reciprocal of each other? Let's try to find the negative reciprocal. For 2/3, its negative reciprocal, what do we get? For its negative reciprocal, I first change the sign. Partial of 2/3 become negative, and then interchange the denominator and numerator. I get 3/2. So here we can see that the reciprocal of M1 is not the same as M2. So they are not negative reciprocal of each other. That means two lines L1 and L2, they are not perpendicular. They are not parallel and they are not perpendicular. Since M1 doesn't equal to M2, and M1 and M2 are not negative reciprocals, then we can say that L1 doesn't parallel to L2, and L1 doesn't perpendicular to L2. That's neither. It's neither parallel nor perpendicular. Next example. Line 1 is 2x plus 4y equal to 7. Line 2 is 3x plus 6y equal to 3. We try to determine whether these two lines are parallel, perpendicular, or neither. So let's find their slopes first. In order to find the slope of a line, we try to rewrite the equation in the form of y equal to ms plus b. Once we get y by itself, the number in front of x is the slope. So let's rewrite the first equation first. First equation is 2x plus 4y equal to 7. Let's try to get y by itself. I can first subtract 2x from both sides. I get 4y equal to negative 2x plus 7. Next, I can divide both sides by 4. I try to get y by itself, so I divide both sides by 4. If I divide both sides by 4, I get y equal to negative 2 over 4 is negative half x plus 7 over 4. So the slope of the first line is negative 1 over 2. Now how about the slope of the second line? Let's rewrite the second equation. Put it in the form of y equal to ms plus b. Once I get y by itself, the number in front of x is the slope. Second equation is 3x plus 6y equal to 7, equal to 3. We try to get y by itself. What we can do first is I can subtract 3x from both sides. I get 6y equal to negative 3x plus 3. Then I can divide both sides by 6. If I divide both sides by 6, I get y by itself on the left side. On the right side, negative 3 over 6 can be reduced as negative 1 over 2. I can divide top and bottom by 3. And the last term, 3 over 6 can be reduced as 1 over 2. So the slope of the second line is negative 1 over 2. Since two lines have exactly the same slope, then we can say two lines parallel. Here we know that M1 equal to M2. Since M1 equal to M2, then we know two lines parallel. Since two lines have the same slope, we know two lines parallel. Next example. Line 1 is 3x minus 2y equal to 6. Line 2 is 2x plus 3y equal to 6. We try to determine whether these two lines are parallel, perpendicular, or neither. So let's find their slopes first. For the first line, we have 3x minus 2y equal to 6. We try to get y by itself. Once we get y by itself, the number in front of x is the slope. So I can subtract 3x from both sides first. I get negative 2y equal to negative 3x plus 6. Then I can divide both sides by negative 2. If I divide both sides by negative 2, on the left side here I get y by itself. On the right side, negative 3 divided by negative 2 is positive 3 over 2 times x. And then from the number here, positive 6 divided by negative 2 is negative 3. So the slope of the first line is 3 over 2. Next, let's try to find the slope of the second line. Second line is 2x plus 3y equal to 6. We try to get y by itself. I can first of all subtract 2x from both sides. Here on the right side, on the left side, I get 3y by itself. On the left side, on the right side, I have negative 2x plus 6. So on the left side, I get 3y by itself. On the right side, I get negative 2x plus 6. Next, I can divide both sides by 3. If I divide both sides by 3, I get y by itself. Negative 2 over 3 is negative 2 thirds. And we put x on the side. 6 divided by 3 is 2. Here, number in front of x is negative 2 thirds. So the slope of the second line is negative 2 thirds. Now, here we can see that M1 and M2, they are not the same. So you can tell these two lines, they are not parallel. How about perpendicular? Are they negative reciprocal of each other? Let's check. For M1, 3 over 2. For M1, 3 over 2, if I take the negative reciprocal, what do I get? For negative reciprocal, I change the sign and then flip the fraction over. 3 over 2 is positive. If I change the sign, it becomes negative. Then I flip it over. 3 over 2 becomes 2 over 3. Here we can see that negative reciprocal of M1 is the same as M2. Negative reciprocal of M1 is the same as M2. So you can tell these two lines, they are perpendicular. Since M1 and M2, they are negative reciprocals. They are negative reciprocals. Then we know that L1 and L2, they are perpendicular to each other. If their slopes are negative reciprocal of each other, then two lines perpendicular. Next example. L1 is 4x plus 5y equal to 10. L2 is 2x minus 6y equal to 7. We try to determine whether two lines are parallel, perpendicular, or neither. So let's find their slopes first. For the first line, 4x plus 5y equal to 10. If we try to find the slope, we try to get y by itself. Then the number in front of x is the slope. So here I can subtract 4x from both sides. If I subtract 4x from both sides, I get 5y equal to negative 4x plus 10. Then I can divide both sides by 5. If I divide both sides by 5, I get y by itself on the left side. On the right side, negative 4 over 5, that cannot be simplified, so I leave it the way it is. Plus 10 over 5 is 2. So the slope of the first line is negative 4 over 5. Once we get y by itself, the number in front of x is the slope. Now let's find the slope for the second line, for line 2. Line 2 is 2x minus 6y equal to 7. We try to get y by itself. What we can do is I can first of all subtract 2x from both sides. I get negative 6y equal to negative 2x plus 7. Next, I can divide both sides by negative 6. If I divide both sides by negative 6, I get y equal to negative 2 divided by negative 6. Double negative become positive, so we get 2 over 6. 2 over 6 can be reduced as 1/3. Then positive 7 divided by negative 6 is negative 7 over 6. So once we get y by itself, the number in front of x is the slope. So the slope of the second line is 1/3. Now here we can see that m1 and m2 they are not the same, so we can tell two lines they are not parallel. Since m1 doesn't equal to m2, then we know that L1 doesn't parallel to L2, they are not parallel. L1 is not parallel to L2. How about perpendicular? Let's look at their negative reciprocals. For negative 4 over 5, if I take its negative reciprocal, negative number becomes positive. And for 4 over 4, I flip over, it becomes 5 over 4. That's not the same as M2. That's not the same as M2. So they are not negative reciprocal of each other. M1 and M2, they are not negative reciprocal of each other. Since M1 and M2, they are not negative reciprocals, then we know that M1 and L2, line 1 and line 2, they are not perpendicular. Since the slopes are not negative reciprocal of each other, we know that these two lines, L1 and L2, they are not perpendicular. So that's neither. Next, let me show you how to find equation of lines. For equation of lines, there are three different forms. The standard form, ax plus by equal to c. The slope-intercept form, y equal to ms plus b, where m represents the slope of the line, and b represents the y-intercept of the line. That's called a slope-intercept form. We see these two forms already. Another form is called the point-slope form. The point-slope form looks like this: y minus y sub 0 equal to m times x minus x sub 0. In this formula, m is the slope. This m and this m, they are exactly the same. They both represent the slope of the line. x0, y0 together form a point. This point could be any point on the line. x0, y0 together form a point. This point could be any point on the line. This is called a point-slope form. That's a point, that's a slope, that's why it's called a point-slope form. The previous formula, that's the slope, that's the intercept, that's why it's called a slope-intercept form. So keep these three formulas in mind. Next, I'll show you how to find equation of lines. Find the equation of the following lines and write the answer in the standard form. First example. Find the equation of the line whose slope is 2 and y-intercept is 3. Find the equation of the line whose slope is 2 and y-intercept is 3. When we try to find equation of line, usually we use the slope-intercept form or the point-slope form. Let me show you the slope-intercept form first, then I'll show you point-slope form later. Let me show you the slope-intercept form first. So here, let me show you how to use slope-intercept form to find equation of line. In a slope-intercept form, we have y equal to mx plus b. Here m is the slope of the line, b is the y-intercept of the line. According to what's given here, we know that the slope of the line is 2, and the y-intercept is 3. Then I can plug in m, plug in b. If I plug in m, I get 2x plus, if I plug in b, I get 3. Plugging m and b, that's an equation of the line whose slope is 2, y-intercept is 3. That's the equation of the line. But now, we try to write the answer in the standard form. Try to put the answer in the standard form. Standard form looks like this. We have x and y on the left side, and a single number on the right side. In standard form, we want to write x and y on the right side, and a single number on the right side. S and y on the left side, single number on the right side. What can we do here? I can subtract 2x, move 2x over, make negative 2x plus y equal to 3. Here I can move 2x over. When I move over, it becomes negative 2x. For y equal to 2x plus 3, I can subtract 2x from both sides. If I subtract 2x from both sides, I get negative 2x plus y equal to 3, which also means I can move 2x over. If I move 2x to the other side, I change the sign. Positive 2x becomes negative 2x. If I move 2x from right side to the left side, positive 2x becomes negative 2x. So here, move 2x over. Then in general, try to make the leading number positive. So I can multiply both sides by negative 1. In general, try to make the leading number positive. So I multiply both sides by negative 1. I get 2x minus y equal to negative 3. That's an answer in the standard form. That's an equation of line in standard form. Next example. Find the equation of the line whose slope is 2 over 3 and the y-intercept is 1. Find the equation of a line whose slope is 2/3 and y-intercept is 1. So same thing, let's write down what's given first. What's given is that slope equal to 2/3. Y-intercept equal to 1. Then use the slope-intercept form. Y equal to ms plus b. Plugging m and b, we get an equation of the line. Plugging m and b, we get an equation of the line. If I plug in m, I get 2/3 of x plus 1. In general, we don't want fractions. For an answer in the standard form, we don't want fractions. So here I can multiply both sides by 3. If I multiply both sides by 3, I get 3y here. 3 times 2/3, it cancels 3 on the bottom, I get 2x. 3 times 2/3, it cancels 3 on the bottom, I get 2x here. And 1 times 3 is 3. In general, for standard form, try to move all letters to the left side. Keep the single number on the right side. So I can move 2x over. If I move 2x over, it becomes negative 2x plus 3y equal to 1. In general, we try to make the leading number positive. So I multiply both sides by negative 1. In general, try to make the leading number positive. So I multiply both sides by negative 1. I get 2x minus 3y equal to negative 1. That's the equation of the line in the standard form. Next example. Find the equation of a line. Passing through a point 1, 2. With slope 3. Next example, find the equation of a line passing through the point 1, 2 with slope 3. So, in the slope-intercept form, y equal to ms plus b. What do we know here? What do we know so far? In the slope-intercept form, y equal to ms plus b. What do we know so far? We know a point on the line, and we know the slope is 3. That's all we know so far. We know a point on the line, and we know the slope is 3. In order to find equation of a line, we need to find b. In order to find equation of a line, we need to find b. How do we find b here? For a point on the line, number 1 represents x coordinate. Number 2 represents y coordinate. First number always represents x coordinate. Second number always represents y coordinate. If I plug in x and y and m, I can solve an equation for b. Here, if I plug in x, y, and m, I can solve an equation for b. So let's plug in m and y and m, and then solve for b. Here, y is 2, m is 3, x is 1, plus b. Solve an equation for b. 3 times 1 is 3. Next, I can subtract 3 from both sides. If I subtract 3 from both sides, I get b equal to -1. 3 plus -2 plus -3 is -1. Here we have m equal to 3, b equal to -1. Then I can plug in m and b, find the equation of the line. Now I plug in m and b. Y equal to 3x plus -1, that means -1. For the equation of line, leave x and y as letters. For equation of line, leave x and y as letters. Plug in m and b. That's the equation of the line. Now, for the answer in the standard form, we must put x. We must put x and y on the left side, and a single number on the right side. So here I can move 3x over. If I move 3x over, it becomes -3x plus y equal to -1. In general, we try to make a leading number positive. So here I can multiply both sides by -1. If I multiply both sides by -1, I have 3x minus y equal to 1. That's an answer in the standard form. Next example. Find the equation of the line passing through a point 4, -1 with slope half. Find the equation of the line passing through the point 4, -1 with slope 1/2. So, in order to find slope of a line, we try to use the slope-intercept form. In order to find equation of line, we try to use the slope-intercept form. Y equal to ms plus b. Write down what's given first. What's given is a point on the line, and we know the slope is half. That's what's given. For the given point, the first number represents x coordinate. The second number represents y coordinate. If we know x and y, we know m, we can plug in h, y, m, and then solve for b. In order to find equation of a line, we need to know m and b. If I plug in s, y, and m, I can solve an equation for b. Here, y is -1, m is half, x is 4, plus b. Now solve this equation for b. Half times 4 is 2. Next, I can subtract 2 from both sides. If I subtract 2 from both sides, I get b equal to -3. -1 plus -2 is -3. Now I know m, I know b. Once I know m, I know b, I can plug in m and b for an equation of a line. For an equation of a line, we leave x and y the way it is, plugging the value for m and b. Here m is half, b is -3. Leave x and y as letters, plugging the value for m and b. And then for the answer in the standard form, we must move the variable to the right side, move the variable to the left side, move x, y to the left side, keep the single number on the right side. What I can do here is I can move this term over, become -1 over 2x plus y equal to -3. In general, we want the first term to be positive. We want the leading term to be positive. So I can multiply both sides by -1. I get half x minus y equal to 3. And also, in general, we don't want fractions here. In general, we don't want fractions in the standard form. So I can multiply both sides by 2. If I multiply both sides by 2, I get x. 2 times half is 1. I get 1x. 2 times y is 2y. 2 times 3 is 6. That's the answer in the standard form. That's the answer in the standard form. Next example. Find the equation of the line. Passing through 2 points. 2, -1. And 4, 7. When we try to find equation of a line, if the slope is not given, we must find the slope first. When we try to find equation of a line, if the slope is not given, we must find the slope first. How do we find the slope here? If slope is not given, we must find the slope first. How do we find the slope here? The formula for slope is always y2 minus y1 over x2 minus s1. That's the formula for the slope. In general, we call the first point s1, y1, s2, y2. If there are 2 points, we call the first point s1, y1. We call the second point s2, y2. Then plug in y2 minus y1, we get 7 minus -1. s2 minus s1, that's 4 minus 2. 7 minus -1, double negative is positive. 7 plus 1 is 8. 4 minus 2 is 2. 8 divided by 2 is 4. So the slope of the line is 4. Once we know slope of the line, write down the formula. The formula is y equal to mx plus b. That's the slope-intercept form. Now, here we can plug in m, and then plug in s and y, solve for b. We know m is 4. What do we plug in for x and y? What do we plug in for x and y? For x and y, we can choose any point. For x and y, we can choose any point. Either use the first point or the second point. Either point is okay. Here, in the first point, the number looks smaller. So I'll plug in the first point for x and y. So here, I plug in the first point for x and y. I can plug in any point to make it easier. In the first point, the number is smaller, so I'll plug in the first point for x and y. Here, 2 represents x, -1 represents y. So I plug in 2 for x, plug in -1 for y, plug in 4 for m, then solve an equation for b. Here I can plug in any point for x and y. Make it easier, let me plug in the first point. Here, y is -1. Slope is 4, m is 4, x is 2. Solve for b here. 4 times 2 is 8. In order to get b by itself, I can subtract a from both sides. -1 minus a, we can consider that's -1 plus -a, which is -9. So b is -9. Now, once I know m, I know b, I can plug in m and b for an equation of line. So here I have y equal to mx plus b. 4 represents m, -9 represents b. Plug in m and b. And then for the final answer, we try to move x and y to the left side. If I move 4x over, it becomes -4x plus y equal to -9. In general, for the final answer, we try to make leading number positive. So here I can multiply both sides by -1. If I multiply both sides by -1, I get 4x minus y equal to +9. That's an equation of the line in the standard form. Next, find the equation of the line. Passing through 2 points, -3, -2, and 1, 6. Find equation of a line passing through 2 points, -3, -2, and 1, 6. In general, when we try to find equation of a line, if the slope is not given, we must find the slope first. For equation of line, slope is always y2 minus y1 over x2 minus s1. That's how we find slope passing through 2 points. In general, we call the first point s1, y1. We call the second point s2, y2. When we know 2 points, that's how we find the slope. Now use the formula. Slope is y2 minus y1 over x2 minus s1. Then on the numerator, 6 minus -2. Double negative is positive. We get 6 plus 2, which is 8. On the denominator, 1 minus -3. Double negative is positive. I get 1 plus 3, which is 4. Then 8 divided by 4 is 2. That's the slope of the line. Now, we can use point slope form. We can use slope intercept form to find equation of line. Slope intercept form is y equal to ms plus b. Plug in m and x and y, solve for b. For x and y, we can plug in any point. We can either plug in the first point or the second point. For x and y, we can plug in either point. We can plug in the first point or the second point. It doesn't matter which point we plug in. Here, let me choose the first point. It could be either point. Let me choose the first point to be x and y. Plug in the first point and plug in 2 for m. Here I get -2 equal to 2 times -3 plus b. Y is -2, m is 2, x is -3. Then solve an equation for b. 2 times -3 is -6. Then I can add 6 to both sides. If I add 6 to both sides, I get b equal to -2 plus 6. -2 plus 6 is 4. I get b equal to 4. Then we plug in M and B, plug in M and B. Leave X and Y as letters, plug in M and B. So Y equal to 2X plus 4. Leave X and Y as letters, plug in M and B. Here M is 2, B is 4. That's the equation of the line. Now, for the answer in the standard form, we try to move X to the left side. If I move 2X over, positive 2X becomes negative 2X. Also, for the answer in the simplest form, we try to make the leading term to be positive. For the answer in the simplest form, we try to make the leading term to be positive. So here I can multiply both sides by negative 1. If I multiply both sides by negative 1, I get 2x minus y equal to negative 4. That's an answer in the standard form. That's an answer in the standard form. For the answer in the standard form, it must be in the form of ax plus by equal to c. We must move x and y to the left side, leave the single number on the right side. That's an answer in the standard form. Next example. Find the equation of a line. Whose x-intercept is 3. And y-intercept is 4. Find the equation of the line whose x-intercept is 3 and y-intercept is 4. So let's write down what's given first. What's given here? X-intercept is 3. X-intercept is 3, that means the point 3, 0. For x-intercept, that's a point located in the y-axis. X-intercept is a point in the x-axis. The y-coordinate must be 0. That's an x-intercept. That's a y-intercept. For x-intercept here, its y-coordinate must be 0. For x-intercept, its y-coordinate must be 0. And same thing for the y-intercept, its x-coordinate must be 0. So for this point, for this y-intercept 4, its x-coordinate must be 0. For x-intercept, its y-coordinate must be 0. For the y-intercept, its x-coordinate must be 0. Suppose x-intercept is 3 here, y-intercept is 4. At this point here, x-coordinate is 3, y-coordinate is 0. At this point here, x-coordinate is 0, y-coordinate is 4. So for x-intercept, its y-coordinate is always 0. For the y-intercept, its x-coordinate is always 0. So here we know 2 points. 3, 0 and 0, 4. That's an x-intercept, that's the y-intercept. Now, in order to find equation of line, if the slope is not given, we must find the slope first. In order to find equation of line, if the slope is not given, we must find the slope first. Formula for slope is always y2 minus y1 over s2 minus x1. That's how we find slope passing through 2 points. In general, we call the first point s1, y1. We call the second point s2, y2. Then plug in, we get 4 minus 0, y2 minus s1, y2 minus y1 over x2 minus s1 over 0 minus 3. On the numerator, 4 minus 0 is 4. On the denominator, 0 minus 3 is negative 3. That's the slope. 4 over negative 3. Positive number divided by negative number is negative. 4 over 3 is not reducible. We leave it the way it is. Slope is negative 4 over 3. Next, let's write down the formula. Slope-intercept form is y equal to ms plus b. That's the slope-intercept form. We know m. Do we know b here? We know m is negative 4 over 3. Do we know b here? B represents a y-intercept. B represents a y-intercept. And here we know that Y-intercept is 4. So we know B is 4. Here B represents a Y-intercept. And here we know that, in the problem we know that Y-intercept is 4. So B equal to 4. Then for the final answer, plugging M and B, leave S and Y as letters. Plugging M and B, I get Y equal to negative 4 over 3x plus 4. Plugging M, plugging B, leave S and Y as letters. That's the equation of the line. That's the equation of the line. But we want to answer in the standard form. For the answer in the standard form, we need to move X and Y to the left side. So here, let me move X to the left side. If I move X to the left side, negative 4 over 3x become positive 4 over 3x plus Y equal to 4. If I move this term over, negative 4 over 3 become positive 4 over 3. And in general, for the final answer, we don't want fractions in the final answer. In general, for the answer in the standard form, we don't want fractions. So I try to eliminate these 3 on the bottom. What I can do is I can multiply both sides by 3. Multiply both sides of the equation by 3. 4 over 3 times 3. 3 cancels this 3 on the bottom. I get 4x. Y times 3 is 3y. 4 times 3 is 12. That's the equation of the line in standard form. That's the equation of the line in standard form. Next example. Find the equation of the line. Whose x-intercept is negative 2. And y-intercept is positive 3. Find the equation of the line whose x-intercept is negative 2. Y-intercept is positive 3. For x-intercept, its y-coordinate is always 0. So that's the point negative 2, 0. For the x-intercept, its y-coordinate is always 0. So that's the point negative 2, 0. Similarly, for the y-intercept, its x-coordinate is always 0. So that's 0, 3. For the y-intercept, its x-coordinate is always 0. So that's the point 0, 3. When we try to find equation of the line, if the slope is not given, we must find the slope first. When we try to find equation of the line, if the slope is not given, we must find the slope first. So let's find the slope first. The formula for slope passing through 2 points is x, let me call the first point s1, y1, second point s2, y2. The formula for slope of a line passing through 2 points is y2 minus y1 over x2 minus s1. The formula for slope passing through 2 points is always y2 minus y1 over x2 minus s1. In general, we call the first point s1, y1. We call the second point s2, y2. Then plug in. On the numerator, y2 minus y1 is 3 minus 0. On the denominator, x2 minus s1 is 0 minus negative 2. Then simplify. On the numerator, 3 minus 0 is 3. On the denominator, 0 minus negative 2, double negative is positive. 0 plus 2 is 2. So the slope of the line is 3 over 2. Next, we try to find the y-intercept. Do we know the y-intercept here? In this problem, the y-intercept is 3. It's given. Once I know m and the y-intercept, once I know m and b, I can plug in m and b. That's the equation of the line. So plug in m and b. If I plug in m and b, I get y equal to 3 over 2x plus 3. Plugging m and b, that's the equation of the line. And for the answer in the standard form, we try to move x to the left side. So I get negative 3 over 2x plus y equal to 3. And in general, we try to make the leading term positive. In general, for the answer in the simplest form, we try to make the leading term positive. So I can multiply both sides by negative 1. I make 3 over 2x minus y equal to negative 3. And also, we don't want fractions in the final answer. So I can multiply both sides by 2. 3 over 2 times 2. It cancels 2 on the bottom. I get 3x. Negative y times 2 will be negative 2y. Negative 3 times 2 will be negative 6. That's the final answer in the standard form. That's the equation of line in the standard form. So far, all I show you here is about how to use the slow-intercept form to find equation of lines. Next, I'll show you how to use point-slope form to find equation of lines. So for point-slope form, y minus y0 equal to m times x minus x0. M represents the slope of the line. This m and this m, they are exactly the same. And x0, y0 represent a point on the line. It could be any point on the line. So point-slope form is y minus y0 equal to m times x minus x0, where m represents the slope of the line. x0, y0 represent a point on the line. It could be any point. Now, let's redo examples from 3 to 8 using point-slope form. Redo problem from 3 to 8 using the point-slope form. Example 3 says, find the equation of a line passing through the point 1, 2 with slope 3. Example 3 says, find the equation of a line passing through point 1, 2 with slope of 3. So let's use point-slope form. For point-slope form, we need to know the slope of a line, and we need to know a point on the line. Here we know a point on the line, 1, 2. For this point, the first number represents x0, second number represents y0. That's a point on the line. And the slope here is 3. That's a point, that's a slope. If we know a point and slope, we can use point-slope form. So this point-slope form, y minus y0 equal to m times x minus x0. That's the point-slope form of a line. Now plugging. Here, when I plug in, I leave x and y as letters. I plug in m, x0, and y0. Leave x and y as letters. So when I plug in, y0 is 2, m is 3, x0 is 1. So when I plug in, I leave x and y as letters, and then plug in numbers for x0, y0, and m. That's the equation of the line. Next, let's simplify. Put the answer in the standard form. So what we can do here is I can distribute 3 first. If I distribute 3, I get 3x minus 3. For the answer in the standard form, we try to move x and y to the left side and numbers to the right side. So what I can do here is I can move 3x to the left side. I get negative 3x minus 2 equal to negative 3. That's 3x plus y minus 2 equal to negative 3. Next, move number 2 over. I can add 2 to both sides. I get negative 3x plus y equal to negative 3 plus 2 is negative 1. And for the answer in the simplest form, we try to make the leading number positive. So I can multiply both sides by negative 1. I can make 3x plus y equal 3x minus y. Multiply both sides by negative 1. I get 3x minus y equal to 1. That's the answer in the standard form. That's the final answer in the standard form. Here we get exactly the same answer. 3x minus y equal to 1. We get exactly the same answer. So either way, we can get the same answer. Either using the point slope form or the slope intercept form, we get exactly the same answer. Now, let's do number 4. Use point slope form. Number 4. Find the equation of a line passing through the point 4, negative 1 with slope 1 over 2. So for number 4, we know a point, which is 4, negative 1. And we know the slope is half. If we know a point, then the point be x0, y0. If we know a point on the line, we let this point be x0, y0. Now once I know a point, I know slope, I can use the point slope form to find equation of line. Let's plug in. Y minus y0 equal to m times x minus x0. M is half. X0, that's y0. So plug in. If I plug in, I get y minus negative 1. If I plug in, y0 is negative 1. M is half. X minus x0. X0 is 4. Now simplify. If I simplify here, y minus negative 1 is the same as y plus 1 equal to half times x minus 4. In general, for the final answer, we don't want fractions. Here we have fraction 1 over 2, so I can multiply both sides by the denominator. I can multiply both sides by the denominator. Multiply left side by 2, multiply right side by 2. If I multiply left side by 2, I get 2y plus 1. 2y plus 2. If I multiply left side by 2, I get 2y plus 2. If I multiply right side by 2, 2 times half, I get 1. It cancels denominator. 2 times half cancels denominator, I get 1. So I get 1 times x minus 4. Then distribute 1. I get 1x minus 4. In general, for the final answer in the standard form, try to move x and y to the left side, number to the right side. If I move x over, positive x becomes negative x. 2y stays the same. If I move x over, positive x becomes negative x. 2y stays the same. If I move 2 over, positive 2 becomes negative 2. If I move 2 over, positive 2 becomes negative 2. Then we have negative x plus 2y equal to negative 2, negative 4 and negative 2 together, consider combining like terms. Negative 4 plus negative 2 is negative 6. And for the final answer in the simplest form, we try to make the leading number positive. So I can multiply both sides by 2. If I multiply both sides by 2, I multiply both sides by negative 1. If I multiply both sides by negative 1, I get x minus 2y equal to 6. In general, try to make the leading number positive. So I multiply both sides by negative 1. Positive x, negative 2y, positive 6. Multiply both sides by negative 1. That's the final answer in the standard form, which is exactly the same as what we have here. X minus 2y equal to 6. X minus 2y equal to 6. So when we try to find equation of line, using either form, either point slope form or slope intercept form, we get exactly the same answer. Number 5. Find the equation of a line passing through points 2, -1 and 4, 7. When we try to find equation of a line, it doesn't matter we use point slope form or the slope intercept form. If the slope is not given, we must find the slope first. So if the slope is not given, we must find the slope first. The formula for slope is always y2 minus y1 over x2 minus s1. In general, we call the first point s1, y1. We call the second point s2, y2. Then plotting. y2 minus y1 is 7 minus -1 over x2 minus s1. It's 4 minus 2. On the numerator, 7 minus -1 is 7 plus 1, which is a. On the denominator, 4 minus 2 is 2. A over 2 is 4. That's the slope. So for point slope form, we must know the slope and a point on the line. Here we know 2 points. We can pick either point. We can pick either point we want. Here, let me choose the second point. Here, let me choose 4, 7 to be my x0, y0. I can pick any point. Here, let me pick 4, 7 to be my x0, y0. Then plug in. The formula is y minus y0 equal m times x minus x0. Plug in m, x0 and y0. Leave x and y as the way it is. y0 is 7. M is 4. x0 is also 4. Then simplify. Let me distribute 4 first. If I distribute 4, I get 4x minus 16. For the answer in the standard form, we try to move all letters to the left side and numbers to the right side. Here I can move 4x over. If I move 4x over, positive 4x becomes negative 4x plus y. If I move number 7 over, negative 7 becomes positive 7. If I move number 7 over, negative 7 becomes positive 7. So I got negative 16 plus 7. If I move 7 over, negative 7 becomes positive 7. Negative 16 stays on the right side. Then if I combine like terms, negative 16 plus 7 is negative 9. For the final answer in the simplest form, we try to make leading number positive. So here I can multiply both sides by negative 1. If I multiply both sides by negative 1, I get 4x minus y equal to positive 9. That's the final answer in the standard form. That's the equation of line in the standard form. Here we get exactly the same answer. 4y minus y. 4x minus y equal to 9. We get exactly the same answer. So it doesn't matter we use point slope form or the slope intercept form. We get exactly the same answer. Next, number 6. Find the equation of a line passing through the points -3, -2, 1, 6. When we try to find equation of a line, it doesn't matter if we use point slope form or slope intercept form. If the slope is not given, we must find the slope first. If the slope is not given, we must find the slope first. The formula for slope is always y2 minus y1 over x2 minus x1. That's the formula for slope of a line passing through 2 points. Then plug in. In general, we call the first point s1, y1. Call the second point s2, y2. Then plug in. y2 minus y1, that's 6 minus negative 2 over x2 minus s1, that's 1 minus negative 3. On the numerator, 6 minus negative 2, double negative is positive, I get 6 plus 2, which is a. On the denominator, 1 minus negative 3, double negative is positive, I get 1 plus 3, which is 4. A over 4 is 2. That's the slope of the line. For the point slope form, we must know the slope and a point on the line. Here I know 2 points. I can pick any point. Here we can pick either point we want. Here let me choose the second point. Let me choose the second point, 1, 6 to be my x0, y0. I can pick any point on the line. Here, let me pick the second point, 1, 6 to be the point. Then plug in. Point slope form is y minus y0 equal to m times x minus x0. Plug in. Leave x and y the way it is. Plug in s0, y0, and m. y0 is 6, m is 2, x0 is 1. Then simplify. I get y minus 6 equal to 2x minus 2. Then for the final answer, for the standard form, we move x and y to the left side, numbers to the right side. I move x and y to the left side, numbers to the right side. If I move 2x over, positive 2x becomes negative 2x. Y stays the same. If I move 6 over, negative 6 becomes positive 6. Negative 2 stays the same. Then simplify, I get negative 2x negative 2x plus y equal to negative 2 plus 6, that's 4. In general, for the final answer in the simplest form, we try to make the leading number positive. So here I can multiply both sides by negative 1. If I multiply both sides by negative 1, I get 2x minus y equal to negative 4. That's the equation of a line in the standard form. That's the equation of a line in the standard form. Here we get exactly the same answer. 2x minus y equal to negative 4. So it doesn't matter what form we use, we must get exactly the same answer. Next. Find the equation of a line whose x-intercept is 3 and y-intercept is 4. When we try to find equation of a line, it doesn't matter we use point slope form or slope intercept form. If the slope is not given, we must find the slope first. The formula for slope is always y2 minus y1 over s2 minus s1. Here, s-intercept is the point 3, 0. Y-intercept is the point 0, 4. In general, we call the first point s1, y1. We call the second point s2, y2. Then plug in. If I plug in, I get y2 minus y1, 4 minus 0, over x2 minus x1, 0 minus 3. 4 minus 0 is 4. 0 minus 3 is negative 3. Positive 4 divided by negative 3. Positive number divided by negative number is negative. 4 divided by 3 is not divisible. I leave it the way it is. That's the slope of a line. And then we know that for point slope form, we must know the slope and a point on the line. Here, actually, we know 2 points. So we can pick any point. Let me pick the first point. 3, 0. We can pick any point. Either the first point or the second point. Here, let me pick the first point. Let me pick the first point, 3, 0. So for this point, that's x0, y0. Now, plug everything to the formula. Y minus y0 equal to m times x minus x0. Let's plug in. Plugging m, plugging s0, plugging y0. Leave x and y as letters. So I get y minus 0 equal to m. M is negative 4 over 3 times x minus x0. x0 is 3. Then simplify. On the left side here, y minus 0 is y. On the right side, I got negative 4 over 3 times x minus 3. In general, for the final answer in the standard form, we don't want fractions. So here I can multiply both sides by 3. We don't want fractions. I can multiply both sides by 3. If I multiply both sides by 3, I get 3y on the left side. On the right side, negative 4 over 3 times 3, it cancels denominator. I get negative 4 here times x minus 3. Then I can distribute negative 4. If I distribute negative 4, I get negative 4x plus 12. Negative 4 times negative 3 is positive 12. And for the final answer, I'm going to move x to the left side, or letter to the left side, number on the right side. If I move negative 4x over, it becomes positive 4x. So the final answer is 4x plus 3y equal to 12. That's the equation of a line in the standard form. That's the equation of a line in the standard form. Here we get exactly the same answer. 4x plus 3y equal to 12. So when we try to find equation of a line, it doesn't matter what form we use, we must get the same answer. We must get exactly the same answer. Next. Find the equation of a line whose x-intercept is negative 2, y-intercept is 3. For the x-intercept, its y-coordinate is always 0, so we get negative 2 comma 0. For the y-intercept, its x-coordinate must be 0, so we get 0 comma 3. When we try to find equation of a line, it doesn't matter we use point slope form or slope intercept form. If the slope is not given, we must find the slope first. Let's find the slope first. Slope of a line passing through 2 points is always y2 minus y1 over s2 minus s1. Then plug in. In general, we call the first point s1 y1. We call the second point s2 y2. Let's plug in. y2 minus y1, that's 3 minus 0. s2 minus s1, that's 0 minus negative 2. In the numerator, 3 minus 0 is 3. In the denominator, 0 minus negative 2, double negative is positive. 0 plus 2 is 2. That's the slope of the line. In order to use the point slope form, we must know the slope and a point on the line. And here we know 2 points. Here we know 2 points. We can pick either point. Let me pick the first point. If I pick the first point, I get negative 2 comma 0. That's x0, that's y0. Then plug in. Once I know the slope and a point, I can plug in. The formula is y minus y0 equal to m times x minus x0. Let's plug in. When I plug in, I leave x and y as letters. Plug in s0, y0, and m. y0 here is 0. M is 3 over 2. x0 is negative 2. If I simplify, on the left side, y minus 0 is y. On the right side, I leave 3 over 2 the same. Inside the parentheses, x minus negative 2, double negative is positive. I get x plus 2. In general, for the final answer, we don't want fractions. For the final answer in the standard form, we don't want fractions. So I can multiply both sides by 2. Since 2 is the denominator, I multiply both sides by 2. If I multiply both sides by 2, I get 2y. I got 2 on the left side. On the right side, 3 over 2 times 2. 2 cancel denominator, I get number 3 by itself. So I got 2y equal to 3 times s plus 2. Next, I can distribute 3 into the parentheses. I got 3x plus 6. And then for the final answer in the standard form, we move x and y to the left side. Numbers stay on the right side. So here I can move 3x over. If I move it over, I get negative 3x plus 2y equal to 6. In general, for an equation in the standard form, we try to make the leading coefficient positive. So I can multiply both sides by negative 1. If I multiply both sides by negative 1, I get 3x minus 2y equal to negative 6. That's the equation of a line in the standard form. That's exactly the same as what we have here. 3x minus 2y equal to negative 6. 3x minus 2y equal to negative 6. So when we try to find equation of line, we can use either the point slope form or the slope intercept form. The answer must be exactly the same. Next example. Find the equation of the line. Parallel to the line, y equal to 4x plus 3, and passing through the point (1, -3). Find the equation of the line parallel to the line y equal to 4x plus 3, and passing through the point 1, -3. In general, when we try to find equation of the line, it doesn't matter we use point slope form or slope intercept form. We must always find the slope first. But here, how do we find the slope? In general, to find slope, we need 2 points. In general, to find slopes, we need 2 points. Slope formula is y2 minus y1 over s2 minus s1. If we don't know 2 points, how do we find the slope? If we don't know 2 points, we cannot use this formula. How do we find the slope here? Here the problem tells us a parallel line. So we can use the parallel line as a reference and then find the slope. Here the parallel line is y equal to 4x plus 3. For equation in the form of y equal to ms plus b, the number in front of x is the slope. So the slope of a parallel line is 4. These 2 lines are parallel. The slope is exactly the same. These 2 lines are parallel. The slope is exactly the same. Slope of this line is 4. These 2 lines are parallel. The slope is exactly the same. That's the slope. That's a point. Once I know a slope and I know a point, I can find the equation of the line. I can use either the slope intercept form or point slope form. Here, let me show you both ways. If I use the slope intercept form, the formula is y equal to ms plus b. So this point 1, -3. 1 is the x coordinate, -3 is the y coordinate. We plug in s, y, and m, solve for b. Here, y is -3, m is 4, x is 1, plus b. Simplify. 4 times 1 is 4. Then I can subtract 4 from both sides. If I subtract 4 from both sides, -3 minus 4 is -7. That's b. Then I plug in m and b into the equation. Leave s and y the way it is. Plug in m and b. M is 4. B is -7. And then for the final answer in the standard form, we move s and y to the left side. If I move 4s over, positive 4s become -4x. Positive y stays the same. They're equal to -7. In general, for equation of line in the standard form, we try to make the leading coefficient positive. Since we have -4 here, I can multiply both sides by -1. If I multiply both sides by -1, I get 4x minus y equal to +7. That's the equation of line in the standard form. So if I use slope intercept form, I get this answer. What if I use point slope form? What if I use point slope form? The formula for point slope form is y minus y0 equal to m times x minus x0. We know the slope already, and we know a point here. We know a point 1, -3. For point slope form, we call this point x0, y0. For point slope form, we call this point x0, y0. For slope intercept form, we call this point s, y. For point slope form, we call this point x0, y0. Then plugging s0, y0, plugging m. I get y minus -3 equal m is 4 times x minus x0 is 1. If I simplify, I get y plus 3 equal to 4 times x minus 1. Then I can distribute 4. I get 4x minus 4. Then for the final answer in the standard form, we move x and y to the left side, move numbers to the right side. If I move 4x over, positive 4x becomes negative 4x. Positive y stays the same. If I move number 3 over, positive 3 becomes negative 3. I get negative 4 minus 3. Negative 4 stays the same. Then simplify, I get negative 4x. I get negative 4x plus y equal to negative 4 minus 3. Consider we are combining 9 terms. Negative 4 plus negative 3 is negative 7. For equation in the standard form, we try to make leading coefficient positive. Here I can multiply both sides by negative 1. If I multiply both sides by negative 1, I get 4x minus y equal to positive 7. That's the equation of the line in the standard form. We get exactly the same answer. So it doesn't matter we use point slope form or slope intercept form, we always get the same answer. Next, find the equation of a line. Parallel to the line. 2x plus 3y equal to 9. Equal to negative 9. And passing through a point (6, negative 2). Find the equation of a line parallel to the line 2x plus 3y equal to negative 9. And passing through the point 6, negative 2. In general, when we try to find equation of a line, it doesn't matter we use point slope form or a slope intercept form, we must find the slope first. In general, to find the slope, we need to know 2 points. But in this problem, we don't know 2 points. If we don't know 2 points, we need to use this equation as a reference. We need to use this equation as a reference and then find the slope. If we don't know 2 points, we need to use the given equation as a reference and then find the slopes based on this equation. Here we have a parallel line. We have a parallel line, 2x plus 3y equal to negative 9. Let's find the slope from this line first. How do we find slope from this line? In general, if we try to find a slope for a line, we try to put the equation in the form of y equal to ms plus b. Try to rewrite this equation in the form of y equal to ms plus b first. Once I get y by itself, the number in front of x is the slope. So let's try to get y by itself. Here I can subtract 2x from both sides first. I get 3y equal to negative 2x minus 9. Then I can divide both sides by 3. If I divide both sides by 3, I get y equal to negative 2 over 3x. Negative 9 over 3 is negative 3. That's the slope. Once I get y by itself, that's the slope. That's the slope of the line. These two lines are parallel. The slope of this line stays exactly the same. This is the slope of the parallel line. Since two lines are parallel, the slope of this equation must be exactly the same. So here, slope is negative 2 over 3. We know a point, we know slope, we can find equation of line. So to find equation of line, we have two choices. We can use slope intercept form or point slope form. Either form must get the same answer. In either form must get the same answer. Let's try slope intercept form first. If we use slope intercept form, the formula is y equal to ms plus b. We need to plug in s, y, and m to solve for b. For the given point, 6, negative 2, 6 represents x coordinate, negative 2 represents y coordinate. So I'm plotting x, y, m, solve for b. Here y is negative 2, m is negative 2 over 3, x is 6. Solve for b. Negative 2 over 3 times 6. I can cancel 6 with the denominator first. 6 divided by 3 is 2. Negative 2 times 2 is negative 4. Then I can add 4 to both sides. If I add 4 to both sides, negative 2 plus 4 is positive 2. So here b is 2. Once I know m, I know b. I can plot in m and b and find the equation. Here the equation is y equal to negative 2 over 3 x plus b. b is 2. For equation of a line, we plug in m, plug in b, leave x and y as letters. That's the equation of the line. Next, we try to write the equation in the standard form. For equation in the standard form, we try to move x and y to the left side and keep numbers on the right side. So I can move negative 2 over 3x to the left side. If I move it over, negative 2 over 3x becomes positive 2 over 3x. In general, for the final answer, in the standard form, we don't want denominators here, we don't want fraction here. So I can multiply both sides by 3. Multiply both sides by the denominator. If I multiply both sides by 3, I get 2x plus 3y equal to 6. That's the final answer in the standard form. If I use Poincare law form, what do I get? If I use the Poincare law form, we know a point, we know the slope, we can use Poincare law form. So for the given point here, 6 comma negative 2, we call 6 x0, call negative 2 y0. The formula for Poincare law form is y minus y0 equal to m times x minus x0. Then plug in. When I plug in, I leave s and y as letters. Plug in m, plug in s0 and y0. Leave s and y as letters. So I get y minus negative 2 equal to m times x minus x0. x0 is 6. Then simplify. Y minus negative 2 is, in the sense, y plus 2. Double negative is positive. On the right side, I get negative 2 over 3 times x minus 6. In general, for the final answer in the standard form, we don't want fractions. So here I can multiply both sides by 3. We don't want fractions for the final answer. So here I can multiply both sides by 3. If I multiply both sides by 3, on the left side I get 3y plus 6. On the left side I get negative 2 times x minus 6. If I multiply both sides by 3, 3 cancels this 3 out. I get negative 2. Now next, distribute negative 2. 3y plus 6 equal to negative 2x plus 12. For the equation in the standard form, we try to move x and y to the left side and move numbers to the right side. If I move negative 2x over, it becomes positive 2x. I keep 3y here. If I move positive 6 over, it becomes negative 6. 12 stays the same. Then for the final answer, I get 2x plus 3y. 12 minus 6 is 6. So the final answer in the standard form is 2x plus 3y equals 6. I get exactly the same answer. So when we try to find equation of line, we can either use Poincare law form or Y-Intercept form. Either way, we must get exactly the same answer. Next, find the equation of the line. Parallel to the line. Find x minus 2y equal to 4. Passing through the point negative 4 comma negative 4 comma 1. Find the equation of the line parallel to the line 5x minus 2y equal to 4, passing through the point negative 4 comma 1. When we try to find equation of the line, it doesn't matter we use point slope form or slope-intercept form. We must always find a slope first. In general, when we try to find a slope, we need to know 2 points. If we don't know 2 points, we need to use the given line as a reference and then find a slope based on this line. Let's try to find slope based on this line here. This is a parallel line. This is a parallel line. 5x minus 2y equal to 4. How do we find the slope for this line? In general, when we try to find slope of a line, we try to divide the slope in the form of y equal to ms plus b. Once I get y by itself, the number in front of x is the slope of the line. So here, let's try to get y by itself. For this line, I can first of all subtract 5x from both sides. If I subtract 5x from both sides, I get negative 2y equal to negative 5x plus 4. Next, I can divide both sides by negative 2. If I divide both sides by negative 4, on the left side I get y by itself. On the right side, negative 5 divided by negative 2, double negative is positive. 5 over 2 is not divisible, so I leave it the way it is. And then positive 4 divided by negative 2 is negative 2. So once I get y by itself, number in front of x is the slope. So the slope of this line is 5 over 2. But since this is parallel line, since this is a parallel line, slope of parallel line must be exactly the same. So the slope of this line, of the line we are looking for, must be exactly the same as 5 over 2. Since two lines are parallel, the slope is 5 over 2. Now once I know slope and know a point, I can use either the point slope form or slope-intercept form to find equation of lines. Here, let me do both ways. Let me first of all show you the slope-intercept form. For the slope-intercept form, the formula is y equal to ms plus b. We know the slope. We need to plot in one of the points for x and y, and then solve for b. Here we know 1 point here. We know 1 point, negative 4 comma 1. For the point negative 4 comma 1, usually I call the first number the x coordinate, call the second number the y coordinate. Plotting x and y and m, then solve for b. Here y is 1, m is 5 over 2, x is negative 4. Plotting x, y, and m, solve for b. Here I have 5 over 2 times negative 4. Negative 4 divided by 2 is negative 2. 5 times negative 2 is negative 10. Then I can add 10 to both sides. I can get b by itself. I can add 10 to both sides. If I add 10 to both sides, I get 11 equal to b. 1 plus 10 is 11. Here b is 11. Once I know m, I know b. I can plot in m and b, find the equation of line. When I plot in m and b, I leave x and y as letters. So I get y equal to 5 over 2x plus 11. b is 11. I plug in m and b and leave x and y as letters. Then try to divide this in the standard form. For the final answer in the standard form, we need to move x and y to the left side. So here, if I move 5 over 2x over, it becomes negative 5 over 2x. Y stays the same. 11 stays the same. In general, for equation of line in the standard form, the leading number must be positive. So I can first of all multiply both sides by negative 1. If I multiply both sides by negative 1, I get 5 over 2x minus y equal to negative 11. And also, we don't want fractions. For equation of line in the standard form, we don't want fractions. So I can multiply both sides by 2. If I multiply both sides by 2, 5 over 2 times 2, I get 5. Negative y times 2 is negative 2y. Negative 11 times 2 is negative 22. That's the equation of line in the standard form. Or I can also use point slope form. For equation of line, I can also use point slope form. If I use point slope form, The formula is y minus y0 equal to m times x minus x0. Here, x0, y0 is a point on the line. M is the slope. We know the slope, and we know a point here. If I use point slope form, negative 4, 1 represent x0, y0. If I use slope intercept form, this point represents x and y. If I use point slope form, this point represents x0, y0. Then plug in. I get y minus 1 equal to m is 5 over 2, times x minus x0. x0 is negative 4. If I simplify, I get y minus 1 equal to 5 over 2 times x minus double negative is positive. I get s plus 4 here. In general, for equation of line in the standard form, we don't want fractions. So I can multiply both sides by 2 to eliminate the denominator. If I multiply both sides by 2, on the left side I get 2y minus 2. On the right side, 5 over 2 times 2 is 5. Then distribute and simplify. If I distribute 5, I get 5x plus 20. For equation of line in the standard form, we need to move x and y to the left side and move numbers to the right side. So here I need to move 5x over. If I move 5x over, it becomes negative 5x plus 2y. If I move number 2 over, negative 2 becomes positive 2. 20 stays the same. Negative 2 becomes positive 2. 20 plus 2 is 22. And for equation of line in the standard form, we want a leading number to be positive. So I can multiply both sides by negative 1. If I multiply both sides by negative 1, I get 5x minus 2y equal to negative 22. That's the equation of line in the standard form. In both forms, we get exactly the same answer. If we solve it in both ways, we get exactly the same answer. Next, find the equation of the line perpendicular to the line y equal to 2/3 of x plus 5, passing through the point negative 2, 3. Find the equation of a line perpendicular to the line y equal to 2/3 of x plus 5, passing through the point negative 2, 3. In general, if we try to find the equation of a line, it doesn't matter we use point slope form or slope intercept form. We must know the slope of the line first. In general, if we try to find the slope of a line, we must know 2 points on the line. Then we can use the formula m equal to y2 minus y1 over x2 minus s1 to find the slope based on 2 points. However, in this problem, we only know 1 point and a perpendicular line. That means we cannot find slope using this formula. We need to find the slope from this perpendicular line. Here we cannot find slope using this formula, since we only know 1 point. We need to find the slope based on this perpendicular line. So we take this line as a reference. This is a perpendicular line. This line is y equal to 2/3x plus 5. The slope of this line is 2/3. Since two lines are perpendicular, their slopes are negative reciprocal of each other. So for the slope, since this line is a perpendicular line, for the slope, we take the negative reciprocal. That means change the sign and flip the fraction over. This number is positive, we make it negative. And then flip 2/3 over, it becomes 3/2. That's the negative reciprocal of 2/3. if two lines are perpendicular, their slopes are negative reciprocal of each other. Now we know the slope from the line. Once I know the slope, I know a point, I can use point slope form or slope intercept form to find equation of lines. Either way is okay. Let me show you the slope intercept form first. The formula for slope intercept form is y equal to ms plus b. We know m is 2/3. We need to find b. In order to find b, we need to plug in a point for x and y. And then based on m, x, and y, we solve for b. Here we know a point, -2, 3. So for this point, the x coordinate is 2, is -2. Y coordinate is 3. I plug in -2 for x, plug in 3 for y, and plug in -2/3, -3/2 for x, for m. Here y is 3, m is -3/2, x is -2. Then solve an equation for b. Here, -2/3, -3/2 times -2, double negative is positive. We can cancel 2 from top and the bottom. What's left is number 3. So 3 equal to 3 plus b, which means b equal to 0. Subtract 3 from both sides, b equal to 0. Then plug in m and b. For equation of line, we plug in m and b. Here m is -3/2. B is 0. For the final answer in the simplest form, for the final answer in the standard form, we need to move x to the left side, move x and y to the left side, and keep the number on the right side. If I move -3/2 over, I get +3/2 x plus y equal to 0. In general, for the equation in the standard form, all coefficients must be whole numbers. We don't want fraction here. So I can multiply both sides by 2. If I multiply both sides by 2, 2 will cancel this 2 on the bottom. I get 3x here. 2 times y is 2y. 2 times 0 is 0. That's the final answer in the standard form. That's the equation of a line in standard form. If I use point slope form, I do the same thing. Write down the equation first. Equation for point slope form is y minus y0 equal to m times x minus x0. M is the slope. x0, y0 is a point on the line. Here a point on the line is -2, 3. For this point, I call -2x0, I call 3y0. If I use slope intercept form, for this point, I use sy to represent -2 and 3. If I use point slope form, I use x0, y0 to represent a point. Then, plugging m, plugging x0, plugging y0, I get y minus 3 equal to m. M is -3/2. X minus x0. x0 is -2. Then simplify. Y minus 3 equal to -3/2 times x minus -2. Double negative is positive. I get s plus 2. That's the equation of the line. Now, we try to write an answer in the standard form. For an answer in the standard form, we don't want fractions. So I can multiply both sides by 2. If I multiply both sides by 2, I get 2y minus 6 here. If I multiply both sides by 2, 2 cancel 2 here, I get -3 times x plus 2. Next, I can distribute -3. I get -3x minus 6. And then, for equation in standard form, we move x and y to the left side, move numbers to the right side. If I move x to the left side, -3x becomes +3x. If I move this -6 to the right side, it becomes positive 6. This negative 6 stays the same. This negative 6 becomes positive 6. Here, left side stays the same. On the right side, negative 6 plus 6 is 0. That's the equation of a line in the standard form. We get exactly the same answer using the slope-intercept form and point-slope form. Next example, find the equation of a line perpendicular to the line 4x minus 3y equal to 6 and passing through the point negative a comma 3. If we try to find the equation of a line, we need to find the slope of the line first. In this problem, since we don't know 2 points on the line, we cannot use the slope formula m equal to y2 minus y1 over s2 minus s1 to find the slope. Since we only know 1 point here, we cannot use this formula. So for this problem, we need to find the slope based on a perpendicular line. So let's find the slope based on a perpendicular line. This is a perpendicular line. (4x minus 3y equal to 6). Let's find the slope from this line first. In order to find the slope from this line, we need to write this equation in the form of y equal to ms plus b first. Once I get y by itself, the number in front of x is the slope. So let's try to get y by itself first. I can first of all subtract 4x from both sides. I get negative 3y equal to negative 4x plus 6. Next, I can divide both sides by negative 3. If I divide both sides by negative 3, I get y equal to, here, negative 4 divided by negative 3. Double negative is positive. 4 divided by 3 is not divisible. I leave it the way it is. And then positive 6 divided by negative 3 is negative 2. So the slope of this line is 4 over 3. The slope of this line is 4 over 3. But this is a perpendicular line. This is a perpendicular line. If two lines are perpendicular, their slopes are negative reciprocal of each other. If two lines are perpendicular, since the lines are perpendicular, for the slope, I take negative reciprocal, which means change the sign, then flip the fraction over. Change the sign, then flip the fraction over. So positive 4 over 3 becomes negative. 4 over 3, if I flip over, becomes 3 over 4. That's the slope of the line. Once I know slope and know a point, I can use either point-slope form or slope-intercept form to find equation of lines. So let me use slope-intercept form first. The formula for slope-intercept form is y equal to ms plus b. We need to plug in a point and a slope to find b. So plug in a point. The point here is negative a comma 3. Negative a is the x-coordinate, 3 is the y-coordinate. So I plug in negative a and 3 for x and y, and then plug in negative 3 over 4 for m. Here I get 3 equal to negative 3 over 4 times x. X is negative a plus b. Then simplify, get b by itself. On the right side, double negative is positive. A divided by 4 is 2. 2 times 3 is 6. Then I can subtract 6 from both sides. Subtract 6 from both sides. B equal to negative 3. Once I know m, I know b, I can plug in m and b for an equation of line. So plug in m and b, I get y equal to negative 3 over 4x plus b. B is negative 3. That's an equation of line. But we want to answer as in a standard form. So that means I need to move x and y to the left side. If I move negative 3 over 4x over, it becomes positive 3 over 4x plus y equal to negative 3. In general, we don't want fractions in the standard form. In the standard form, we don't want fractions. So I can multiply both sides by 4. If I multiply both sides of an equation by 4, I get 3x plus 4y equal to negative 12. That's the equation of a line in the standard form. Or I can use point slope form. Or I can use point slope form from the equation of the line. If I use point slope form, the formula is y minus y0 equal to m times x minus x0. Here, m represents the slope of the line. x0, y0 represent a point on the line. Here, a point on the line is -a, 3. That's a point on the line. We call this point x0, y0. Then plotting x0, y0, and m. If I plug in y0, I get y minus 3 here. M is -3/4. If I plug in x0, I get x minus -a. Simplify. Double negative is positive. I get x plus a. For equation of line in the standard form, we don't want fractions in general. So here I can multiply both sides by 4. Since I don't want fractions, I can multiply both sides by 4. If I multiply both sides by 4 on the left side, I get 4y minus 12. On the right side, 4 cancel this 4 on the bottom. What's left is -3 times x plus a. Next, I can distribute -3. I get 4y minus 12 equal to -3x minus 24. Then, for equation of line in the standard form, we need to move x and y to the left side and numbers to the right side. If I move -3x to the left side, it becomes positive 3x. 4y stays the same. If I move -12 over, it becomes positive 12. -24 stays the same. Then -24 plus 12 is -12. So we get 3x plus 4y. That's the equation of a line in the standard form. That's the equation of a line in the standard form. So it doesn't matter we use slope-intercept form or point-slope form. Answer must be exactly the same. We must get exactly the same answer. Next example. Find the equation of the line. Perpendicular to the line 2x plus 5y equal to -12. And passing through the point 6, -3. If we try to find the equation of a line, we must find the slope first. Since we don't know 2 points on the line, we must find the slope using the perpendicular line. This is a perpendicular line. (2x plus 5y equals -12). Let's find the slope for this line first. In order to find the slope of a line, we need to get y by itself. Put it in the form of y equal to ms plus b. And once I get y by itself, number in front of x is the slope. The number in front of x is the slope. So let's get y by itself first. I can subtract 2x from both sides. I get 5y equal to -2x plus 12. Next, I can divide both sides by 5. If I divide both sides by 5, I get y on the left side. On the right side, I get -2/5 x plus 12/5. So the slope of this line is -2/5. Since this is a perpendicular line, we know that if two lines are perpendicular, their slopes are negative reciprocal over each other. Since this is a perpendicular line, for the slope, we take the negative reciprocal. Since this is a perpendicular line, for the slope, we take the negative reciprocal. So, -2/5 become positive. 2/5 I'll flip it over, become 5/2. So the slope of the line is positive 5/2. Once I know the slope and know a point, I can find equation of the line using either the slope-intercept form or point-slope form. If I use the slope-intercept form, The formula is y equal to ms plus b. We know m. We need to plug in a point for x and y, then solve for b. We know m here. We need to plug in a point for x and y, then solve for b. Here, the point here is 6, -3. So that's an s coordinate, that's an y coordinate. Plug in s and y and m, then solve for b. Here, y is -3, m is 5/2, x is 6, plus b. Simplify, solve the equation for b. Here, -3 stays the same. On the right side, 6 divided by 2 is 3. 3 times 4 is 15. Then in order to get b by itself, I can subtract 15 from both sides. -3 minus 15 is -18. That's b. Once I know slope, I know b. Once I know m, I know b, I can plug in m and b. Find the equation of the line. So here I get 5/2x minus 18. Plugging m and b, leave s and y the way it is. Plugging m and b. That's the equation of a line. Next, we try to rewrite this equation in the standard form. For equation of a line in standard form, we move x and y to the left side. Here, if I move 5/2x over, it becomes -5/2x. Y stays the same. -18 stays the same. In general, we try to make all coefficients positive. So I can multiply both sides by -1. I get 5/2x minus y equal to 18. And also, for equation of line in standard form, in general, we don't want fractions. So here I can multiply both sides by 2. If I multiply both sides by 2, 5/2 times 2, 2 get cancelled. I get 5 by itself. X stays the same. Y times 2 is 2y. 18 times 2 is 36. That's the equation of a line in the standard form. That's the equation of a line in the standard form. If I use point slope form, if I use the point slope form, the formula is y minus y0 equal to m times x minus x0. M is 5/2. x0, y0 represent a point on the line. Here, a point on the line is 6, -3. So I can use 6, -3 as my x0, y0. For a point in Y-intercept form, this point represents x and y. For a point in point slope form, this point represents x0, y0. Then plugging x0, y0, and m. Find equation of line. Here I get y minus -3 equal to 5/2 times x minus 6. Then simplify. Rewrite this equation in the standard form. Here, y minus -3, double negative is positive. I get y plus 3. On the other side, 5/2 times x minus 6, I leave it the way it is for now. In general, for equation of line in the standard form, we don't want fractions. So I can multiply both sides by 2 first. If I multiply both sides by 2, I get 2y plus 6. 5/2 times 2 is 5. 2 get cancelled. I get 5 times x minus 6. Next, I can distribute 5. If I distribute 5, I get 5x minus 30. And then, for equation of line in the standard form, we try to move x and y to the left side and move numbers to the right side. If I move 5x over, it becomes -5x. If I move 6 over, positive 6 becomes -6. So I get -30 minus 6. Then add them up. -30 plus -6 is -36. In general, for equation of line in the standard form, we don't want negative sign in the front. So I can multiply both sides by -1. If I multiply both sides by -1, I get 5x minus 2y equal to 36. That's the equation of line in the standard form. Here we get the same answer. In general, when trying to find equation of line, you can either use slope-intercept form or point slope form. Either way will give you the same answer. Next, Let's look at some special case. Find the equation of the horizontal line passing through the point 3, 4. In the beginning of the class, we know that a horizontal line always has a form of y equal to some number, y equal to b represents some number. A horizontal line always has a form of y equal to some number. So this is a horizontal line. It always has the form y equal to some number. Since it passed through this point, since the horizontal line passed through the point 3, 4, the y coordinate here is 4. So this line is y equal to 4. That's an answer. That's a very, very special case. Horizontal line always has the form y equal to some number. Since it passed through the point 3, 4, its y coordinate must be the same as this point. So that's an equation y equal to 4. This is a horizontal line passing through the point 3, 4. That's a very special case. Next, find the equation of the horizontal line passing through the point -2, -5. Again, it's a horizontal line. Equation of horizontal line always has the form y equal to some number. Since it passed through the point -2, -5, the y coordinate at this point is -5. So this equation is y equal to -5. That's the equation of horizontal line passing through the point -2, -5. That's a very, very special case. Next, find the equation of the vertical line passing through the point -1, 6. Find the equation of the vertical line passing through the point -1, 6. In the beginning of the class, we know that a vertical line always has a form of s equal to some number. So this is a vertical line. It must have the form of s equal to some number. And what's x? What's the value here? This is a vertical line passing through the point -1, 6. The s coordinate at this point is -1. So x must be -1. That's the equation of a vertical line passing through the point -1, 6. Next example. Find the equation of the vertical line. Passing through the point -4, -3. We know that a vertical line always has a form of s equal to some number. And what's the value here? Since this vertical line passing through the point 4, -3, the s coordinate at this point is 4. So for this equation, s must equal to 4. That's the equation of the vertical line passing through the point 4, -3. Those are special cases. Next, find the equation of the line passing through the point -2, -4. With slope 0. Find the equation of a line passing through the point 2, -4 with slope 0. What does 0 tells us? What does slope 0 tell us? In the beginning of the class, we know that when the slope is 0, the line is a horizontal line. The line is horizontal. When the slope is 0, the line is horizontal. Since this line has 0 slope, it must be a horizontal line. So, when slope is 0, we know that this line is a horizontal line. When the slope is 0, we know this line is a horizontal line. Horizontal line always has the form of y equal to some number. And what's y here? What number should I put here? Look at the point. This horizontal line passing through the point 2, -4. The y coordinate here is -4. So for this line, y must equal to -4. That's the equation of the line. That's the equation of the line. That's a special case. That's another special case. Next. Find the equation of the line. Passing through the point -2, -3 with undefined slope. Find the equation of a line passing through the point -2, -3 with undefined slope. In the beginning of the class, we know that if a line has undefined slope, it must be a vertical line. If slope is undefined, the line must be vertical. So, if a line has undefined slope, it must be a vertical line. So, undefined slope means this is a vertical line. Undefined slope means this is a vertical line. We know that vertical line always has the form of s equal to some number. And what number should I put here? Look at the point. This line passing through the point -2, -3. At this point, the s coordinate is -2. So for this line, x must equal to -2. That's the equation of a vertical line passing through the point -2, -3. Those are special cases. Next example, find the equation of the line passing through points 5, 1 and -4, 1. When we try to find the equation of a line, if the slope is not given, we need to find the slope first. The formula for slope is y2 minus y1 over x2 minus s1. In general, we call the first point s1, y1. We call the second point s2, y2. Then plug in. y2 minus y1 is 1 minus 1 over s2 minus s1. That's -4 minus 5. On the numerator, 1 minus 1 is 0. On the denominator, -4 minus 5. Try to combine like terms. -4 plus -5 is -9. 0 divided by -9 is 0. So the slope is 0. When the slope is 0, that means this line is a horizontal line. If the slope is 0, this line is a horizontal line. We know that horizontal line always has the form of y equal to some number. Equation of horizontal line is always in the form of y equal to some number. And what number should I put here? Look at the point. Their y coordinate is 1. So y must equal to 1. Since y is a line passing through both points, y must be the same as their y coordinate. So that's the equation passing through these 2 points. Which is a horizontal line in the form of y equal to 1. Next, find the equation of the line. Passing through points 3, 4, and 3, -2. When we try to find equation of lines, if the slope is not given, we need to find the slope first. If the slope is not given, we must find the slope first. Formula for slope is always y2 minus y1 over s2 minus s1. In general, we call the first point s1, y1, and we call the second point s2, y2. Let's plug in. y2 minus y1 is -2 minus 4. x2 minus s1 is 3 minus 3. -2 minus 4 is -6. Try to combine like terms. -2 plus -4 is -6. The denominator, 3 minus 3 is 0. -6 divided by 0 is undefined. We cannot divide any number by 0. The denominator cannot be 0. So this is undefined. When the denominator is 0, this number is undefined. When we have an undefined slope, that means this is a vertical line. When we have an undefined slope, that means this is a vertical line. And we know that vertical line always has a form of s equal to some number. What number should I put here? Look at the s-coordinate of the points. Look at the s-coordinate. This line passing through both points, and the s-coordinate is 3. So x must be 3. That's the equation of the line passing through these 2 points. That's the equation of the line passing through these 2 points. So those are some special cases.